Hey guys, and welcome back to a new crash course, this time for Spring Boot with Kotlin. So this will really be a full crash course for building REST APIs using Spring Boot and Kotlin. So for all of you who are either completely new to building REST APIs, and this would be the first time in your life to do that, but also for those of you who are already a little bit familiar with what that is and maybe have built some REST APIs before, but are new to Spring Boot specifically. So what do you actually need in order to follow along? The only piece of knowledge that I assume in this crash course is to at least have some basic Kotlin knowledge. So Kotlin will be the programming language we use here for Spring Boot. So Spring Boot is a Java-based backend framework. But since Java and Kotlin are programming languages that are fully interoperable, so we can use these together in a project, we can use Kotlin code for Java-based frameworks, for example, like here. So that's fully flexible. I personally like Kotlin way more than Java, which is why we stick to Kotlin here in this course. If you don't yet have Kotlin knowledge, then good news for you, because I recently released a 3-hour crash course on learning that. If you follow through this crash course and you understand at least 80% of it, you are definitely ready to follow through this one. But in regards to REST APIs, what that actually is, things like backend frameworks, what that is, why we need a backend framework, why we should stick to it, you don't need any knowledge about that. I will give you everything in this course. And one last prerequisite is you need IntelliJ. IntelliJ is the IDE, the programming environment in which we will type our code for this Spring Boot backend. So go to the link that I will put in this video's description. Here you can download this. This is the ultimate version. That one is paid. But if you scroll down a little bit, you will find the free community edition, which is completely fine for this video. And before we actually get into coding, I want to leave a few words on what a REST API actually is, why we are building this, why this should be useful for the real world, then why specifically we should use Spring Boot, or why that's actually a pretty good backend framework. And then I will share something about what we are actually going to build here, so what kind of use case this backend from this course will have, and then we'll finally get into coding. So if we take a look at what an API is in the first place, leaving the REST keyword aside. API stands for Application Programming Interface, which still sounds very abstract, but in the end, an API is just a way to let two applications interact with each other. And specifically when talking about backend development, where we want to develop a server structure, so a program that is running on a remote server somewhere on a machine that we fully control, and not on a client's device, like a website or a mobile app, which is running on a device that is owned by some of your users maybe. No, with backend development, we want to build a program, so an API that runs on some kind of distant server that has the purpose to accept requests from clients, process these in some way, and then respond with a proper response. And of course, mobile apps, websites, back-end technologies, back-end frameworks can all be built in different programming languages. They can run on different operating systems. So there needs to still be some way to let all these communicate with each other. And that is exactly what an API is. So you can really think of it like a restaurant menu, which is a way to tell the customers of that restaurant which specific foods you're offering. But that's also a way that the kitchen understands in order to make and prepare these foods for the customer. So that's really what an API is. It's really just a list of specific pieces of functionality that you are offering, where the client, so the mobile app, the website, can say, okay, this is actually the piece of data that I need. So the client uses the API in order to communicate with the backend server, which then receives that request, processes it, and sends the response back to the client. And now coming to REST API specifically, since that is a term that you hear very often together with APIs, a REST API is in the end just an API that works via URL. So where URLs are the primary way to say, okay, this is the piece of data that I want as a client, as a mobile app, for example. So if we are here on the JetBrains website where we wanted to download IntelliJ, then the moment we actually access that website, we're doing nothing else than calling a REST API endpoint. And the endpoint is just this URL with optional parameters. So here, for example, in my case, I was redirected to the download for macOS. And we can also see this in our browser by right-clicking, hitting Inspect to open the developer tools. And if we then drag this in here, this is in the end the HTML structure that helps the browser to visualize the response from the API. But in the end, we just said, hey, please, the servers from JetBrains, show us the website's HTML structure for the IntelliJ download page, specifically for macOS. So we send this request, hey, please show us this for this particular URL. The server from JetBrains then processes this in order to give us this HTML structure, which is really nothing else than text, but structured text that our browser understands in order to visualize this response for us. And specifically here in the Chrome developer tools, we can also see this network tab in which all specific API calls, so calls to this REST API from JetBrains, are being shown. Right now, they aren't because we haven't made any of these yet, at least since we've opened this network tab here. So if we move this away and reload this page, then we will see lots of stuff happening here. So every single line that we see here is in the end a request that was made to the JetBrains servers. So you can see certain JavaScripts were loaded here. You can see which specific request method that was made with. That's all something we get to later in this course, what that means. But all the information about this particular request. But there are lots of requests being made here to an API that you are probably not even aware of when just using your browser in your day-to-day work life. Another very common form of data exchange is JSON. So HTML is of course one way to share structured data from a server to a client that the client can then interpret and visualize, but not all clients are, for example, HTML-based. For example, in mobile apps, HTML is usually not that useful in order to display some visual elements. That's something that's more common with web development, but on mobile development, we still, of course, need a way to parse and interpret the data that the server responded with. And on mobile devices, but also for websites, by the way, that's very commonly done via JSON. So here for the card JSON, for example, that was some kind of JSON structure. If we preview this, okay, that's now empty, but maybe we can find something here. This would be a JSON structure where we have a hierarchy of data that is attached. So that's just another form to bring structure into data that clients can then understand and decide about what it wants to do with this data. So here, for example, we can attach a list of certain languages that may be supported, a specific product, some status or so. And that is also the form of data exchange that we will use in this course. So REST APIs are really just a way to let a client communicate with the server via URLs. So we define multiple so-called URL endpoints where each endpoint is just consisted of a unique URL. So for example, if we just access jetbrains.com, this would result in a different piece of data being returned than accessing this particular download page. So different URLs lead to different responses. And in the end, this REST API just gives us, like the restaurant menu, not with specific foods, but actually with specific URLs that we can call, that we can send requests to in order to get the data that we need in a client device. Okay, so much about what a REST API is, but what is now a backend framework like Spring Boot that we will use here in this course? Well, technically, we could build our completely own architecture or technology in order to receive incoming requests, in order to process these. But imagine how much actually belongs to providing this base functionality of what a REST API's job is. We would need a way to actually parse the incoming requests. We need a way to keep our server actively running, so it's always there to be able to receive and process requests. There are things like security features, so very often, for example, we need to save certain authentication tokens on the backend server, at least on a remote database that the backend server has access to, which then grants specific users privileges to access certain parts of this API, certain parts of the data. Like if you're running an Instagram, then of course, only you should be able to edit your profile and not other people. So there is lots and lots of functionality that we typically need in such REST APIs that is always the same. And this is the problem that such backend frameworks like Spring Boot solve, that they just give us this base foundation, this base of high-level toolkits that we can work with in order to build a specific API. So that we don't need to care about implementing our own security algorithms, which would be pretty bad yet anyways, that we don't need to care about actually making sure to keep the server running, that we don't need to care about logging any type of requests or so in order to see what went wrong with specific users. So we just need a fair amount of less configuration in order to start building REST APIs. And Spring Boot specifically now is just a Java-based backend framework, but as I said, Java and Kotlin are programming languages that are fully interoperable, so we can write Kotlin code for such a Java-based framework, which is what we're going to do here. But Spring Boot is actually just a layer on top of the Spring framework. So the Spring framework is just a very comprehensive framework that provides functionality, utility for Java-based enterprise applications. So this is not just limited to building server architectures, but to any form of enterprise applications we build with Java. So just really, really big software. Spring exists since around 2003. And then a bit later, Spring Boot was developed, which is actually a layer on top of these Spring libraries and Spring frameworks in order to just make it a bit easier to build backends. So backend programs like we're doing here with Spring and in Java or Kotlin. All right, I talked a lot, but I think that was quite necessary information if you're new to this stuff. Just some last words about what we are actually going to build in this practical course here. In the end, I want to give you a solid foundation of building Spring Boot backends here with a range of common features you need. So what we will build is a cloud node-based backend. So later on, we will build simply a note-taking app, or if you want a note-taking website where you can have nodes with a title, a description. We can pick a color, for example. And these nodes that users will then create in our app will be saved in a cloud environment. So we will save this in a remote database that we manage here on our backend. And if a specific user can own a specific set of nodes, then that also means we need some form of authentication. So we need to say user A owns these 5 nodes and no other users than user A are allowed to actually retrieve these nodes from our API. So it also means we need something in the app on the final website that lets a user register and log in. So we will implement an email and a password authentication here. And after being logged in, all the nodes from that particular user will be fetched from our REST API that we built here. All right, let's get into it. Once you've installed IntelliJ, you can create a new project there in order to just write your Kotlin code. However, don't just create a blank project in IntelliJ directly, because we need this base Spring Boot setup. So there's already a set of functionality, set of libraries that are already pre-included that we may want to pre-include in a Spring Boot project in order to work with that. Now, if you only have the IntelliJ Community Edition, the free one, then I don't think there will be an option for you to directly create a Spring Boot project in IntelliJ. But that doesn't mean you can't follow along, since there is this Start Spring IO website, which is in the end just a website where you can configure an initial Spring Boot project, say, okay, that's the programming language we want to use. We want to use Kotlin here. Also Gradle Kotlin, by the way. I'll share something more about what that is in a moment. You can choose the version of Spring Boot, and then in the end, you just download a zip file that you can then open in IntelliJ without needing to create the project over there. So just make sure to use the same configuration as I'm here. So Gradle Kotlin, using Spring Boot version 3.4.3. Maybe if you're watching later, you can also choose a later stable version, but then it may happen that certain parts are a little bit different than in this video. So I would recommend, if you have the option, to use this version. Then for the group, we typically use our company name. Same here for the package name. We can give this a name of Spring Boot Crash Course, for example. Let's use the same one here for the artifact. Actually, that should be not a real word, but something like Spring Boot Crash Course. So should be one word or separated with dashes. Also, I will use underscores. And then for the description here, we can use real words. So Spring Boot Crash Course, something like packaging can stay at jar. So this is just at the end, we want to be able to package our entire code in order to also be able to run it on a server architecture, for example. And we can pick a Java version, since everything, as I said, is Java based, and we need Java in order to run this whole thing. That already comes with the IntelliJ installation, so you don't need to install this manually, but we need to pick which Java version we want. This would in the end decide about certain language features we could use, because later Java versions introduce new language features both for Java and Kotlin. But let's just leave this at the pre-selected option. That is completely fine to use Java 17 here. And on the right side, we can actually see some dependencies. So a dependency is in the end just something our program depends on. And that is in the end, if we click on Add Dependencies, those are really just modular pieces of functionality that we may want to include in such a backend framework, in such a backend program, I mean. And you don't need to completely decide on all these here during project creation. This is just a way to make this a bit nicer. But also if you forget about a specific piece of functionality, a specific library, that's how we call this, then you can also, of course, add this later. But here, for example, there are certain containers, certain libraries that you can use if you're building a web application. So primarily a backend for websites. And there are lots of these templates, which you can see makes Spring Boot a super mature backend, because there are lots of predefined packages of functionality, like Spring Security, for example. That is one that we will use, since we of course need to deal with some security sensitive data, like the passwords that a client sends to our server. We somehow need to save those passwords, or at least a different kind of representation, which we'll get to later in this course. But working with plain text passwords is of course always quite dangerous, which is why we want to do this as little as possible. I would say we leave this aside here and rather just copy paste my dependencies that I've already prepared later in this project, and you also already see how that works. So let's just include Spring Security here and then click generate, because that will give us this zip file. So simply make sure to extract that zip file in some kind of folder where you want to store your IntelliJ projects, and then you can open this in IntelliJ. So if you're launching IntelliJ for the first time, there will be just a big prominent window to open an existing project. You select the folder that you've extracted out of the zip file, and if you're already using IntelliJ, then you will know how to open a project there. There we are in IntelliJ. I've opened the project, and I would say the first thing that we can do here in order to learn what all this is about is go through the project structure of a typical empty Spring Boot project, so we understand which parts it consists of, at least going through the important parts. So if we open our package here, our root package, then you will see something like this. Maybe the first thing that also opens for you is this build.gradle KTS file. If it's already open for you, you don't need to reopen it. If not, then feel free to double click on that, because that is indeed an important file. So Gradle, at least in our project, is the so-called build system for the project, because in the end, we can't just take our code as a simple text file and run that. No, there actually needs to be some sort of logic that takes our entire project, packages it into something, into a format that we can really run, so that we can execute our server's source code. And that is one of the responsibilities of Gradle. So it just runs the right tasks in the right order to compile our code, to package it into a jar file, for example, so an executable Java file, and then be able to really see something here in our console when we run the server. Another big responsibility of Gradle is to manage our so-called dependencies. So if there are specific software toolkits, specific libraries that our server depends on, where we say, okay, we need, for example, Spring Boot security functionality, which we definitely do need here, then we can tell Gradle, hey, please include this security functionality in our project, so we have access to all those classes and functions that this package provides. And that's exactly what we do down here in this dependencies block. So every Gradle dependency just links to such a string, which really just tells Gradle, hey, that is the place where you can fetch and download those classes and files from this, in this case, Spring Boot starter security package. And this is also the first place where I want to change something about this project, because we need quite some more dependencies than we have here. So I will replace these entire dependencies with what I've copied before. You will find the link to the entire project here in GitHub down below. So go to the video description now, click on the GitHub link, then in GitHub, click on this build.gradle KTS file, and simply also copy paste those dependencies, paste them in your project, and then you're ready to go. So specifically what we've included here is some Spring Boot starter web functionality. So that's just some toolkit that brings us basic functionality for Spring Boot backends. We have the Spring Boot starter data MongoDB that gives us Spring Boot related functionality in order to talk to a MongoDB instance, so our remote database that we will set up here in this course. The same thing also in a reactive way that I don't think is necessary for this particular project. We have the security package, we have security crypto, so that we're also able to apply some cryptography. You will see later how that can be needed. And down below here, you can also find some dependencies regarding JSON web tokens, so JWT tokens. That will be the type of authentication mechanism that we choose here. I will explain much more about that when we implement that part, but it's in the end just a token, so a string that the client gets and that will authenticate the client that they are a valid logged in user later on. But once you've pasted all these, you want to click on this little button that appears here to synchronize these changes so that Gradle will download all these toolkits, all these libraries we call them, and then we can use them in our code. Let's take a look at the code next. So here in our source package, in main, that is really where our main source code is located in, and you'll find this initial Spring Boot crash course application. And that's really just the entry point of our program. So the moment we click run here, we can actually do this already. Then this main function will be called. It will call some kind of run application function, which under the hood just calls some function of Spring Boot and really runs our server. You can see that our server actually finished with exit code 1. That is not what should happen. Maybe for you it keeps running, but if this happens for you, then you can scroll a little bit up and it tells you exactly what went wrong. It tries to run the server on port 8080, but that apparently was already in use. So if there is some kind of other program running in the background on your machine on that particular port, well, then we just need to pick a different port during development. So the port is in the end really just the specific door to which traffic should be routed after all. So imagine your machine is just a big hotel And every single running program that could accept such traffic, such network traffic like a backend server, has its own room in the hotel. And if now incoming network traffic is coming to your machine, to your IP address, then that traffic or your machine still needs to know which specific door, which specific program it needs to direct this traffic to. And that is exactly what is done with a port. So if we want to send traffic to a specific backend application, then we also need to specify the port that application is running on, so the machine knows where to direct this traffic. We can change this port by going to resources, because here's another important file, which is the application.properties file. If we open that, then right now we really only see the application name, but that is really the global properties file where we can put our application specific configuration. So here we can configure our database, we can configure how our backend runs. For example, we can set the port it should be running on. And that works via the server.port attribute. And you can see the default is 8080. We could set this to something like 8085, for example. If we rerun this, then at least if there is no other program running on this port, you can see now our server is actually not exiting with the exit code 1, but it will keep on running. And now, if the console is open like that, it will actively listen for traffic. So this is now the main server console that logs everything that currently happens here. And I would say the first thing that we start to implement here is being able to save nodes in our remote database. Because as I mentioned, we want to build a backend, a cloud-based node-taking backend kind of, where we can just save nodes we create on a client side, we save them in a remote database, so we can also download these on different devices later on, for example. And for that, we of course need to be able to somehow persistently store these nodes in a database. And that will be our MongoDB instance. Specifically, what we will be using here is a cloud database, a cloud version of MongoDB, which is called Mongo Atlas. So that means the database instance won't be running directly on the same server instance here our backend will be running on, but it's actually somewhere in the cloud. The server environment is managed by MongoDB. So we don't need to care about that anymore, because that's just the easiest way to set this up. It's also free for development purposes, so you can really just follow along just like I do. For that, we need to go to mongodb.com here /products platform atlas database. So this is the type of database that we use here. Of course, there are lots of different databases you could stick to. This is a so-called NoSQL database. So we don't interact with it via SQL queries, but MongoDB has its own query format, and specifically it stores data as key value pairs. So similar to how you maybe know this from JSON structures, where we say, okay, we have an email field and the value of that is a particular user's email. What you now need to do is, if you don't have an account on MongoDB, you need to hit get started and actually enter your details here or sign up with Google in order to be able to start using this. If they then prompt you to create a specific instance already, then feel free to do that. There is a specific free version, a free tier that you can stick to, and you can perfectly follow through this video. That's actually exactly the same tier that I'm using here. Since I already have an account, I can show you the exact same sign-up process. But once you've actually created an account, it will look somehow like this. So you actually have some sort of project that you've created here. In my case, I call this YouTube for all YouTube-related projects. And then you have these clusters. That's in the end just an isolated part of your MongoDB instance. So here, for example, one cluster that I've already created is Spring Boot Experiment. That is the database instance kind of that I experimented with in order to prepare this course. But if you create a completely new account for MongoDB here on Mongo Atlas, then you are likely prompted to also create such a new cluster, which is just needed in order to store data here remotely. That is why I also want to lead you through this process. So I go to clusters, but you are likely prompted with that before. And I'll actually create a new project here, because I think only then it will look like, for me like it does for you. So we can go to YouTube, and then we click on New Project in order to create a new MongoDB project. So we can say Spring Boot Crash Course, for example. That is the name of our project. And in the project, we can then deploy multiple so-called clusters. We can click Next, so we don't need any tags here. That's optional. You can see we need to add certain members and set permissions. We can add that. So if you're working with multiple people on this database instance, you can say, okay, there are some colleagues you maybe have, and they are allowed to access this much of your database. But if you already have an account here, then obviously you are the owner, and then you have full permissions. So if we now click Create Project, you will see something like this. So you can see right now there is no cluster for this new project, and therefore this will also be the case for you. If we now click create in order to create a cluster, because that's necessary in order to just deploy a database instance, then there is this free tier that I talked about. So this is something you want to click on. We can give this cluster a name. I don't know, we could call it Spring Boot Crash Course Cluster. I don't know, something like that. Pick AWS as the provider or something else if you prefer that, but that won't have any impact on how this database instance works. And for a region, you typically want to pick something that is as close to where your user base is as possible, since then network traffic is obviously faster. Or in this case, rather as close to where your real server instance is deployed to. Since this MongoDB instance will be running on a different server, since it's a cloud instance, then our real Spring Boot backend will be running on. So once we've selected all that, free tier, AWS, Frankfurt, or whatever is close to you, we click Create Deployment. And then we need to set up a connection security. So by default, Mongo Atlas wants us to secure this connection to the database so that we say only machines from this specific IP address we specify are allowed to actually talk to our MongoDB instance. That's just a security feature so that even if someone would get your so-called MongoDB connection string, which is just kind of a MongoDB specific URL that grants full access to your database in order to connect to it, that even if someone would get access to that connection string, they couldn't access your database if they wouldn't use that connection string from exactly the IP address that you've specified. And of course, if your server, your Spring Boot backend is deployed to a clear server that has a clear static IP address, then it makes a lot of sense to restrict the communication to your MongoDB instance to only that IP address. Because then only your specific server where you've deployed your Spring Boot backend is able to talk to your MongoDB instance. Of course, if you want to connect to your MongoDB instance locally as well, so from your local machine during development, then you also need to make sure that you add your local IP address. So for me, MongoDB already inferred this. This has already been enabled to allow local connectivity. With local IP addresses, it can of course happen that these change. So the moment you restart your router or so, then you will get assigned a different IP address, and then the connection to MongoDB might fail. If it fails for some kind of weird reasons, it's likely a reason that your local IP address changed. You can also temporarily just allow access from all IP addresses, that works, but then you don't have that security backup anymore because anyone who really gets access to your specific connection string could connect to your database, drop it, do whatever with it. So let's just leave this as it is here. Just keep this in mind. If connection at some point fails, it's likely because your local IP address changed. You need to create a database user. So every database needs to be accessed via a specific user. We can then set certain privileges for that user. So here, that is already the default user inferred from my email address. We can give it a password, which I will actually change here. So I won't use the default password. And then we can say create database user. I will actually give it a username of Philipp. That is a bit clearer. Create database user. There we go. We get a check for both. Proceed to connect. That is what we click on next. Now we get to this connection screen. So here we will now get instructions on how we can really integrate this specific instance of MongoDB into our program, into our backend. If you want a more graphical way to interact with this database, I recommend to take a look at Mongo Compass, so that it just allows you to have just a graphical user interface where you can connect to this instance and easily see what data is contained in your database, but that also works here in the browser. The most important thing that we now need to take care of and look at is this specific connection string. So that's exactly the connection string that I mentioned. If someone has that and also has your database password for this user that you've just said, they get full access to your database. So keep this secret and make sure to properly protect your database via the network access. So only from specific whitelisted IPs, and everything else is blocked. So we want to copy this, and that's actually already everything we need in order to store data here. So if we now go back to IntelliJ, we somehow need to tell our code, hey, this is the connection string that we use. Please use that one to connect to the MongoDB instance in order to just store data there. And the configuration for the connection string itself also happens here in the application properties file. So the attribute name for that is spring.data mongodb.URI. So that is actually the connection string, which we could paste here, but obviously we would need to swap out the database password in here in order to let MongoDB connect to that. You could now also swap this out here, but that would be a quite bad practice. Why? Well, because this application properties file contains your entire application properties. Your Spring Boot backend needs that to run, which is why this is also typically pushed to version control. So to your GitHub repository, for example. And the moment it's pushed to GitHub, everyone who has access to that GitHub repository can see your actual connection string. We don't want that. Instead, we want to work with so-called environment variables. So those are just kind of secret variables that you can set at the OS level. And then you can say the value of this is actually the value behind this actual environment variable. And with Spring Boot specifically, we can set these environment variables for development by clicking on our run configuration here, clicking edit configurations. And then by default, it won't show any fields for environment variables, which is a bit weird. But I think we can click on modify options here in order to just show more options, specifically these environment variables here. So if we click on that, then a new field appears for environment variables. We can click on this little paper icon, whatever. And here we can then add new environment variables that our program is launched with. But these environment variables are then not baked into our actual source code, so therefore would not be visible in version control, but we can still reference these in our code, which is exactly what we want. So we want to click on new, and we call this environment variable something like MongoDB or MongoDB URI or connection string, something like that. And the value of that is now our actual connection string. Just make sure that you actually really swap out the password now, otherwise you won't be able to connect to that, which I will quickly do, of course, off screen. And once we've did that, we click OK here in order to apply that. And now here in our application properties file, we really just need to refer and reference this just set environment variable. That works with $ and curly braces. And we reference the MongoDB connection string environment variable. And this will then automatically be set by Spring Boot. So this way, this file here is completely safe to commit and push to version control because it does not contain the string itself, but really just the reference that we want to get the string from our environment variable set. Maybe we also get some logs here if we actually run this backend again, that the connection was successful. No, actually not, because it says database name must not be empty. Interesting, that is because we did not specify a specific database name in our connection string. So one such project in MongoDB, Mongo Atlas, can contain multiple distinct databases, and we need to say, hey, that is the one we want to connect to, or that is the one you should create if there is no database with that name yet. So we need to adjust the connection string, and I will just show you my password here. It's really just a random one, and then I will delete the cluster anyways, so nobody of you will be able to connect to this after this. So there we go, just a random Spring Boot test, but that's not what we want to change, but rather here, where the first slash comes, we need to say this is the database name to connect to. So in our case, this would be our nodes database, since that is what we store there, or the, I don't know, whatever you want. So we call this our nodes database, click OK, apply, OK, and rerun this. Let's take a look at if it crashes again. No, it doesn't. I actually don't know if there is some log that says it connected successfully to our MongoDB instance, but there is at least no log that says that wasn't successful. The best way to test this is, of course, just write some code that really connects to this and saves some data to our database. That is what we want to start with. So whenever implementing a database where we want to save a set of data, we need to first declare how this set of data actually looks like. So in the context of our application, we need to tell MongoDB, hey, this is what a node is in the context of our application, and that's the data we want to save with that. So here in our package, we want to create a new package, which I will call model, because this contains our database-specific models, so just data classes after all. Here we can then create our node model, so new data class, and we really just make sure to describe what a node is. So a node has a title, a node has some content, a node might have a color, which we store as a long value, so we can also save the color and always display the same node in the same color client side. A node is certainly created at a specific time and date, which is an instant here. So an instant is really just a reference to a specific timestamp. That is important to store because later on we might want to just sort our nodes chronologically, so based on when they were created. In order to do that, we of course need to know when a node was created or updated. And lastly, with every single document, that is how we call something like that. So a specific element in a specific collection. So here we would have the nodes collection. So just a collection of specific database documents of specific nodes with specific titles, specific contents, a specific color, and so on. Every specific document in MongoDB must be uniquely identified via an ID. And that is also what we can set here. So if we need access to this MongoDB generated ID inside of our source code, we can say, hey, we have an ID of type object ID. That is the MongoDB specific ID type, which is, as I said, randomly and automatically generated by MongoDB. And we can just default initialize this with object ID.get. In order to tell MongoDB that this is actually the main ID for this node, we need to annotate this with @ID. And we can import the class ID. If we wouldn't include this ID line here, then the node documents would still get this ID field, but we wouldn't be able to interact with it since we would have no reference to these nodes. So right now we declared what a node is, what data it consists of, that we have an ID, but we still need to tell MongoDB that this is actually a real document, so something we can store in a specific collection. And that is why we need to annotate this with document. Hit Alt-Enter to import that, and then we can give this just a collection name, so for example, nodes. Then we will see, okay, here we have our nodes collection that stores specific instances of nodes. All right, so now that we have this data class, we, on the other hand, need a way to interact with our database. So we need to say, this is the specific functionality for our nodes collection specifically. So we need to be able to insert new nodes into our database. We might need to be able to query certain nodes in the end for a specific user. And we may need to be able to delete certain nodes. So where do we declare this functionality so that we're able to run these queries in our code? That happens in a so-called repository. So a repository is just a way to interact with certain data sources like our MongoDB instance. And specifically MongoDB for Spring Boot has lots of ways or adds lots of functionality that makes it very, very easy to interact with a MongoDB instance. So in our root package, I want to create a new package that we maybe call a data source or repository. Let's call it repository. If we may also want to group this together with the model package in a database package. So we say we have new package database, we take our model package, we move this in there, click refactor, and then in the database package, we also create a repository package. In here, we can then create a node repository. So a repository that is able to interact with our nodes collection. This will be an interface because the way MongoDB for Spring Boot works is that we don't actually need to define the queries on our own that we need in order to interact with our database, at least not simple queries, but a lot of that is actually generated by the MongoDB plugin or by Spring Boot itself in order to give us the specific queries we need. You will see in a moment how this works. If we have a repository that should interact with a MongoDB instance, it needs to be a Mongo repository. So let's make it a Mongo repository. And now we need two generic arguments. On the one hand, a type T, that is the type of documents we store in this particular repository, which is node, and it needs an ID generic. So the specific type of ID that uniquely identifies a document in this collection. In our case, it's this ID here, which is of type object ID. So we take the object ID type here, and then we have we successfully implement this Mongo repository interface. You also can use your own custom unique data types. So for example, a string, then you would need to swap this out with a string. But in general, I would recommend to use MongoDB's object ID instance because that's really what MongoDB is based on. Object IDs, by the way, also contain a timestamp. So you could also sort your documents by their object ID in order to sort them chronologically. And the cool thing about MongoDB Spring Boot is, as I said, a lot of default functionality, a lot of default queries are already generated without us needing to specify specific functions that execute these queries. So what I mean by that is we could really just have a blank node repository, and as long as it implements this Mongo repository interface, we already get quite some query potential. So let's just have a temp function here that has this repository instance, so our node repository now, just to see what kind of functionality we have here. So we can say repository, and there's a lot of queries that is already generated that we could already use. So for example, to count the number of elements here, to find all, so to just get a list of all nodes, to save a new node is already there, to delete the entire collection, to delete a specific node, to count those nodes that fulfill a certain condition. We can delete nodes by ID, we can delete a single node by ID. So a lot of these queries we can already immediately make use of without having to say, okay, this is now the specific database query in order to find all nodes. There must be a query that must exist, but it is already, that complexity is already hidden from us thanks to this MongoDB Spring framework. Of course, these are all simple queries to find a node by ID, to delete a node by ID. The moment you just need a bit more customized queries, you need to implement these on your own. And there's actually only one single query we need to specify on our own here that isn't automatically included here. And that's actually a query that makes use of another field I intentionally haven't specified yet in the node collection, in the node document, because it's maybe not immediately clear that we need this. Well, this data here kind of already makes up a node, but on server side, where we store all nodes of all users together in a single collection, we of course also need some sort of reference. Who owns this node? So which user has created that? That is why, in addition to these fields, we also need an owner ID field, which is also an object ID, not the primary ID one that identifies the node, but one that identifies the owner that we will then use in a different collection to store all users. So the owner ID here is a separate field. And then in our node repository, let's get rid of this temp function, we can extend this initial functionality that this Mongo repository already gives us with more functionalities that all use the specific naming conventions here from MongoDB, so we can find, and it already gives us these specific suggestions here by a certain field name, for example, or find by title contains, which would generate the query for us where the title field of our node contains the title that we pass as an argument here. That's not what we want here. We want to find all nodes by their owner ID. So we say find by owner ID. We open this here. We pass in the owner ID that we want to find all nodes from, because multiple nodes can now have the same owner ID, since one user can create multiple nodes. And this will give us a list of all nodes from that particular owner. And just specifying this function here in our interface will generate the real query for this under the hood, so we don't need to worry about that. It's really just important that you consider this naming convention from MongoDB. So if you give this function a different name, then MongoDB will have no idea what you actually want to query for. Okay, so now we've defined the type of documents we want to store. We've defined the ways how we need to interact with this specific collection of nodes. Like, we need more ways than just finding them by owner ID, but as I said, the other ways are generated for us to just delete a node, for example, by their ID. So the next way, or the next thing we need to do is we need a way for a client device, a website, a mobile app, for example, to interact with this backend to query all nodes for that particular user. So our backend can then process that, interact with our MongoDB instance, get all the nodes for that user, and then respond with this list of nodes to the client. So the client can display that in the app or the website. And this works via so-called REST controller. So what REST means, you've already learned, just a specific API that works via URLs. And a controller is really just the unit here in the context of Spring Boot that accepts such REST requests. So such requests to a specific URL with some parameters, with a body maybe, so with information about the node the user has created, because that's obviously something only the client knows. So we want to go to our root package and create a new controllers package. And in there, we create a node controller, which is a normal class. All right, so in this node controller, we now need to outline those functions that should get called when a specific client, so a mobile app, for example, makes an API call, a REST request, to that specific URL for this particular function here in this node controller. So we now need to think about which API in regards to nodes we want to expose to clients. So how should clients be able to modify our nodes collection, for example? One thing they definitely need to be able to do is to send a node from the client where the user has maybe created a node in their note-taking app or note-taking website and now say, okay, I want to save this in the remote database. So we need a way to save a node. So we just have a function save. And this function obviously needs some parameters. It needs to know the information about the node that the client wants to create. And the communication here from client to server works via JSON, because by default, we can't just send real class instances here via the network. No, there needs to be some way of serializing that in order to deserialize that on the server again. So there needs to be a way to format data that both the client and the server understands in different programming languages that is just consistent across technologies, across programs, across machines. And JSON is one of them. HTML would be another. So in the end, what we want to have a data class called node request. And in this data class, that is now the request body, that's how we call this, we outline which specific data we need from the client who makes the request in order to just correctly save a node with all the data that belongs to it on the server side. Specifically, that is a title, which you definitely need to know. That is the content, that is the color, So val color, which is a long value. And well, if we take a look in our node document here, we save more fields. So we have the owner ID, we save a created at timestamp, we save a node ID. And technically, we could also make this node document the request type. But then the client would also need to provide data like when the node was created. Who is the owner ID? What is the actual ID of the node? And those are things we rather want to leave up to the server. Because if we leave such things up to the client, we give it a lot of control. The client could simply choose a completely wrong created at timestamp and would cause problems on the server side. So we really only want to let the client give as much control as necessary. And since only those 3 things about a node that we don't know server side, that only the client knows, are those 3 fields: title, content, and color, since that's all values the user decides to set. So that's why we specify another specific node request data class that is really just meant to parse an incoming request with the data that we need here. Something that is interesting for us is still the node ID. Here we pass this as a string because this needs to be serializable via JSON. And I don't think MongoDB object IDs are serializable. I'm not sure, or they might result in some other kind of JSON structure, not just in the raw ID. But the thing is, if the user wants to update a particular node, then we need to say, hey, that is the node with the specific unique ID that I want to update with these new fields. However, if the user wants to create a new node, then the user won't have an ID yet. The client device won't have that ID yet. So we will leave this at null. So effectively, this save function will be a so-called upsert function that either inserts a new node if there is no node with that ID yet, or if we have an ID of a node that exists in the DB already, then it will be updated with all the other details specified. On the other hand, if we have a node request, we may also need a node response. So that is the data that our server responds with if the client wants to know something about a node. And here we might now give a little bit more data, so specifically the ID, which is now non-nullable, because the moment the server has properly saved a node, we know it must have an ID. We give it a title, we give it a content, we need to respond with the color as well, so the client knows which color was previously set and synced with the server. And here we may also want to actually share the created at timestamp in form of an instant, because that's still an information that's valuable to know for the client, but it's something the client should not be completely free about when the node is about to be saved on the server side. So we can just set it to the exact same timestamp on the server when this node request is coming in. So we can now say in our save function, this takes in a request body of type node request. That is what the client sends. And when a client sends a request in order to save a node, we want to call this function. So something we also need to consider now is what is actually the specific URL that we want a client to call in order to save a node. And in order to do this, we can't leave the node controller class as it is. Spring Boot actually heavily works with these annotations. You've already seen this here with node. So this is now just to declare a document. This is to declare the ID of a specific MongoDB document. And the same way it works with these annotations to mark certain common types of classes like controllers here as exactly those in order to take away a lot of complexity from us. So what we want to do is we want to annotate this class with REST controller to tell Spring Boot, yo, that's a controller class that is used in order to control REST requests. So in order to just call these functions here when a user or when a client makes a request to a specific URL endpoint. What we can also do is we can give this a so-called request mapping. So a request mapping will just map all requests to a specific relative URL. What that will mean, you will see in a moment. So if we set this to nodes, then this node controller will accept requests that go to this specific relative URL. So if we have a URL for our finally deployed server of example.com, or let's say nodes.com, then with this request mapping, we say that if a request is being made to nodes.com/nodes, then this REST controller here, this node controller, is responsible for handling these. Also, for example, if we make a request to something like nodes/123, which would be a mandatory argument, for example, which could be a node ID. If we want to get the details of a specific node ID, that would be a common URL format. However, if a request would be coming into, I don't know, nodes.com/account, then this REST controller would notice, okay, that doesn't match with this relative URL. So this controller would not be responsible for handling requests through the account endpoint. So for that, we would need another controller that has a request mapping of /account. So I think you get the idea, but still we may need multiple endpoints for this /nodes URL. So we need to be able to insert a new node. We need to be able to delete existing nodes. And we need to be able to retrieve all nodes that belong to the user who makes the request. So this single request mapping does not satisfy that, because we'll have multiple functions here that handle different types of requests. So there still needs to be a distinction for us to say on the server side, okay, this request should save a node, even though going to the same endpoint, this request should delete one, and this request should retrieve all nodes for a user. And this distinction of multiple different types of requests being made to the same endpoint, to the exact same URL after all, that is made via the different HTTP methods. So the 4 most common HTTP methods, those are not all, but the 4 most common are GET, so GET requests, POST requests, PUT requests, and DELETE requests. And via this HTTP method, we know on the server side what the client wants to do. GET requests, as the name says, are typically just used if the client wants to get certain data. That's not used in order to modify something on the server side in order to push a new node into our database. No, that's something the client would use to say, okay, just give me all of my nodes. POST requests, on the other hand, are used to really create a new resource server side, like a node, for example. So the client has information about a new node, wants to save that server side, and that would be a typical use case for a POST request. PUT requests are used if a resource on the server side should be updated, so completely updated, completely swapped out. And delete requests are used to really delete a resource, as the name says. But as I said, there are more. For example, patch requests are also fairly common if only single fields of a node or so should be updated. But that's something we don't need here. For this save function, what we need is a POST request. And we can tell it that by saying add POST mapping. So that way, by annotating the save function with POST mapping, all requests that go to our main URL, whatever kind of URL we deployed this backend to later on. Here locally, it would just be localhost. So in our local case, all requests that go to HTTP localhost colon our port name, which is 8085 I said, /nodes. If we now make a POST request here to this route, then Spring Boot will notice, okay, this goes to /nodes. This node controller is responsible. It's a POST request, so it will execute this specific POST mapping function in this node controller that's responsible. So we really don't need to call these functions in these controllers on our own, but Spring Boot will take all that work from us and call it. We just need to tell Spring Boot, hey, this is the function that should be called for POST endpoints. And now when we save a node, we of course need to somehow reference our node repository. So we definitely need to pass this in the constructor here, our node controller. We can say we have our repository of type node repository, and then we can access this here in our save function. And if we also want the save function or the POST endpoint here to return specific data again, for example, about the finally saved node with all the information that belongs to it, actually just what we have in this node response, then we can just make this return a node response. But all the serialization effort to parse the node response data class to JSON and parse the request from incoming JSON, all that effort is taken away from Spring Boot. So we can really just say repository or node repository. We save a new node. That is one of the pre-generated functions that really just takes in an entity, a node class after all. And we want to just create a node, so our document. We set the title to the title that comes from the request body. Same for the content, body.content. We say color is body.color. Created at is now something that we don't get from the client, but here we can just say instant.now. So whenever the request is incoming, we just say, okay, now this node was created. And well, we also need to pass an owner ID. How do we know which owner now created this node? Well, ideally, what we could of course do is we could extend our node request by saying we also want to pass an owner ID. And then we could say owner ID is an object ID. So we need to take this incoming string owner ID and convert it to a MongoDB object ID. And we pass in our body owner ID. We could do this, but this would mean that the client needs to say, this is who I am. And maybe you already have a feeling that this is not totally secure because the client could technically send anything to our server. And the moment the client would therefore get the user ID of a different user, they could just say, hey, I'm actually the other user and the node should be created for the other user. So if user A is making a request but says, hey, I'm user B, then the node will be created for user B. User A could therefore also delete nodes from user B just by having their owner ID. And that's of course not really secure. For now, we will still leave the code as it is, but later on in this course with authentication, I will show you an approach that is much safer and where the client can't easily tamper with this information anymore. So we just leave this for now in order to be able to test this. This save function will actually also return the finally inserted node. So we get the node here. And one more thing we need to consider is that if the ID of the incoming node request is actually null, is actually non-null, that means the user wants to update the node. So we in the end just deal with creating and updating both in a single endpoint. In that case, it's fine to leave this as a post request. So here, if there is a node ID, so if the body.id, if that's actually a non-nullable string, we can do this with let, then we return an object ID with this existing ID. So it refers to this ID if it's non-nullable. If it is null, we just return a new randomized object ID here. And just by assigning this existing ID here, the save function will notice, okay, that exists, so it will upsert this instead, update all the contents here of this node that has changed. And then we can say we take this node that was inserted into our database and we return a node response with the information that we now know. So node ID to hex string, that is how we convert a Mongo object ID to a real string. The title is node.title, content is node.content, the color is node.color, and created at is node created at. If you do need this behavior more often than just once here, to take a node document from MongoDB and convert this to a node response, so if multiple endpoints just respond with such a node response by taking a specific node from the DB, then it makes sense to create a so-called mapper for that. So that's really just a function that takes a node, extends that, calls it toNode response, for example, and then returns the node response. So it pretty much just takes this behavior to construct a node response out of a node into a separate function. So you could just say return node.toNode response, which saves you this code here if you need this a lot of times. But that's really already the post mapping in order to create a node. What we also need is we need a way to have a get mapping. So we say get mapping in order to get all nodes from a specific owner ID. So we can say function find by owner ID, which responds with a list nodes after all, or node response if you want. The node response I don't think contains the owner ID, which the client actually doesn't even need to know what their ID is. So we may also want to say node response. Here we of course again need the owner ID. For now I will really hard code it, but as I said, we'll of course adjust this later on when we implement the authentication mechanism. You can really just say return repository find by owner ID. That is the only custom function we have defined in our interface. And we pass in the owner ID. Let's actually just pass this here to the function. Get requests actually work a bit differently typically than post requests. So with post requests, we typically have a real body. So oftentimes just a JSON body that outlines a lot of bundled content like for a node. With get requests, since we typically don't want to push new data, we don't work with bodies, but we rather just work with request parameters. So which specific type of information we need to access. So we may just need to know the owner ID in this case in order to retrieve the right nodes for the right owner. This would work via these parentheses here and saying that we maybe have, actually not parentheses here, but here in the function parameters, we can define at request param, so request parameter, in order to declare an optional parameter by setting required to false. Just say, hey, this is optional, or actually this is not optional because we need an owner ID in order to retrieve a valid set of nodes. And then we say, okay, we have the owner ID, because then we can really just take this from the URL that we make the request to, pass this to our object ID, and then actually take the nodes here and map these to simple node response objects. And let's actually create a simple mapper for this, just to show you how this works, because now we have this twice in order to take a node object and convert this to a node response. We could really just say we have a private function node.toResponse, and we say this returns a node response. And then we take the exact same code here, cut this out, put it in here, just that we remove these node variable names since the node's title and content is already inferred from the node we call this extension function on. So really just like this. Then here in our save function, we can say we return node.toResponse, and here we can just take all nodes and also map these to response objects. And of course, if you need these mappers in multiple files, then it makes sense to not make these private, but put these in a separate file, separate mappers package, for example. That would scale better than always putting these in the controller, but here it's a really simple use case. So what this request parameter here actually does is it makes sure that we can make a request, for example, a get request now to this same URL while specifying the owner ID via a URL parameter. So something like this. So if we make a request to this URL, this would retrieve all nodes for the owner with this ID. As I said, we will remove this. This is not a very good approach to fetch nodes, but it's really just to be able to try out what we've built so far before also having to build the entire authentication mechanism. What happens if we run this? Something interesting will happen where you might be a little bit confused. You could see, we do see our server logs just like before. But the interesting thing is that our node controller and our node repository are both apparently created, so our program does not really crash. And well, right now you could think we don't yet use this node controller. But actually, let's go into our program called Postman, which is a program you can use in order to test such REST requests, in order to simulate API calls to a specific URL. That's perfect to just test such a local development backend to see which data you can send and which data you then get back from the backend. So feel free to just download Postman if you also want to follow along, because otherwise, without any client that we have yet with functionality connected to this backend, it's really hard to test this. If we create a new query here, so HTTP, then you can see we can select the request type, get, post, put, and so on. And we can then specify the URL we want to send this to. So just make sure your server runs and you type HTTP. We're not using HTTPS here locally. That would be something you need to set up when deploying the backend. I want to send this to localhost, to the local machine that this is running on. We intentionally specify the port and then send the request to the node's endpoint. Let's first of all actually create a node. So we say post, we then go to body because we want to attach a body for our node. In order to attach JSON, we need to say raw and select JSON here. And then we can create our JSON request. So on the one hand, we do need to pass a title for the node. We say hello world, for example. We can then say content is my node content, for example. And the color, well, it's just a long. This won't be a valid color here, but let's just pass in a valid value. And if we click send, why do we get unauthorized here? So first of all, if you're new to REST APIs, this number that we get back here with this kind of status is what we call the status code. So an HTTP status code. The status code is something that is always returned and responded with a specific REST request. So no matter what kind of request we make to a REST API, there's always a specific response code that tells the client, so here, and in this case, Postman, what went wrong. And 401 unauthorized in the end just means we are lacking authentication. And authentication in the context of REST APIs always means we have some level of security that prevents random people from making random requests to our backend, but we say, hey, you need to be authenticated. You need to be a valid user of our backend, for example. And even though we did not explicitly set up any security mechanism yet, Spring Boot still tells us we are unauthorized. So we are lacking the authentication details that would be required. And that is because we are using Spring Security. So here in our build.gradle file, we've added this Spring Boot starter security dependency, which sets up a certain security, a certain level of security by default that also makes sure that authentication is required even here in our test environment. And if we take a look here in the Run tab, there's actually this security generated password, which gets generated as a new random string every single time we run our backend. So the moment we rerun this, there will be a different password. There we go, there it is. But we need this password in order to talk to our test backend, unless we set up some other security config, which we'll also do, which is required if you want to push this to production at some point. But for now, we did not explicitly change anything about the security setup yet. But if we take this password and we go back to Postman and now tell Postman to use these authentication details by going to authorization, selecting basic auth here as the auth type, and then we can select a username password authentication. That's a very simple form of authentication where the username is simply user. That is the default of Spring Security, which you could override in the Spring Boot application settings. But the password is now our randomly generated security string. If we now take a look at the body again, make sure we have a valid JSON body, select JSON here, click send, we still get unauthorized. And I will tell you in a moment why, but I will also show you that if we change this to get now, and we send the exact same request to the same endpoint, then we do get bad request. So that's also an error code, but it's a different one. And the fact that it's a different one already shows that we are authenticated, because if we wouldn't be authenticated, if our password would be invalid here, for example, if we just make it invalid and prepend an A, then we get unauthorized because that is checked by Spring Boot first. If we are authenticated, then Spring Boot will, of course, check for certain other errors, and bad request is another status code that says, yo client, you sent invalid data to the backend, where Spring Boot just doesn't know what to do with it. Why is this being thrown here or responded with for this get endpoint? Well, because here in Spring Boot, in our node controller, For the get mapping, we say we have a required parameter for the owner ID. And the client, in our case Postman, did not explicitly provide this owner ID. So if we would provide this by saying !owner ID and we set this to something and hit send, we get another specific status error code. In this case, internal server error. Internal server error means something crashed on the server side. So not the backend itself crashed, that is kept alive by Spring Boot, but something went wrong. So our input led to some kind of exception being thrown on the server side, so the server could not properly process the request. And that's in general what you can also already detect here at the status code. If the status code starts with a 5, that means something went wrong on the server side. If it starts with a 4, that means the client did something wrong, like attach invalid data or so. If it starts with a 3, that means the server redirects the request. So for example, if a URL has changed, then the old URL can redirect the client to the new URL, and the status code starting with a 3 indicate that. All codes starting with a 2 pretty much just mean that was successful. So the most common one would just be HTTP 200, which means, okay, request was successful. And status codes starting with a 1 are purely informational. So for example, that the server received and handled the request, but it's not fully finished yet, but the client can send more. But what I'm trying to say is, this shows that with our user and password combination, we are now able to authenticate to our server. But if we choose post here, remove the owner ID and still send more or less valid data, we get this unauthorized error. And the reason is called CSRF. That stands for cross-site request forgery. And we could go really deep into this, but it's in the end just a safety mechanism for server-based sessions. So it's actually a type of attack that users could make in order to steal certain session tokens. In our case, we are using so-called stateless sessions. And I will say something more about that later on, but we will use JWT tokens, which are so-called stateless sessions. In these cases, this protection for CSRF attacks does not really apply. Still, the default behavior is for post and put endpoints to enforce this protection unless we work with that otherwise. But as I said, in our case, we can disable this protection, since for the type of token that we use for authentication, this won't apply. We still need to tell this Spring Boot. So we can say we create a new security package in which we create a security config. This is something we need to do anyways in order to configure all the stuff for our production environment later on. So what a valid authenticated request would be. We need to annotate this with configuration. This is just another Spring Boot specific annotation that says, hey, we want to use this class or the contents of it to configure something. And then we can have a function that is called filter chain. And I will say something about that in a moment, which gets an HTTP security object and returns a security filter chain. So this is actually the signature that Spring Boot now expects. The HTTP security object that is used in order to configure our security related functionality of this backend. And it then returns a security filter chain, which is then just processed internally by Spring Boot in order to apply these security related changes. And we actually also need to annotate this function with bean. Might sound a little bit random if you're new to Spring Boot. I will say something more about all these annotations we have here in a moment and what a bean is and all that stuff. Let's for now really just be able to test this here by saying when we return HTTP security. And here we can then say CSRF and we actually disable that. So we get this CSRF object in this Lambda and we can say CSRF.disable. And we may also want to say for the session management that we set this to stateless session management. I'll also say something about that when we actually implement our real session tokens. So it.session creation policy, and we set this to session creation policy.stateless. And then afterwards we can call that build in order to really construct such a security filter chain object. We will get back here to this class later on in order to really implement our production-based authentication. But for now, let's keep this as it is. And if this is still unclear, really don't worry. I will get back to what all this means in a moment. But let's relaunch this because I really just want to be able to show you that we have something that works. We again take our new security password, copy it, go to Postman, make sure to click on authorization, basic auth, and replace the previous password with this one. Previously, we got unauthorized. If we now send this same request with the same body again, we now get bad request. Okay, that's at least some progress, but our server apparently again says the request data we sent was invalid. let's take a look at Spring Boot again. So specifically here in Node Controller, we can take a look at what kind of request this actually accepts. So here, for the node request, the ID is optional, so we can leave that at null. But you can see it also expects an owner ID, which we did not explicitly pass. So that's something we need to pass in Postman as well, because it's a mandatory argument, it's not nullable. And something I'm noticing is that we also need an annotation, by the way, for this request body to say, hey, please take the request body of the request and parse that into our node request so we can really take that here. That was something I just forgot about. But if we do this and we relaunch this once more, we should hopefully be able to really construct nodes. We take this password again, go to Postman, swap out the authorization header again. You can, by the way, also override this password, so you don't always need to swap this out. So we could do this in the application settings. I will show you this in a moment. But if we now actually take the request and we also provide a valid owner ID, which could be 1, 2, 3. I'm not sure if MongoDB will probably not be able to create this since it's not a valid MongoDB format. So I would say we actually get rid of the owner ID, since then MongoDB will generate that for us. So here we get rid of that and we just say every single node we try to push to our API, we just kind of create for a new owner. That's not the final functionality yet, of course, but let's actually also quickly override the security settings here. That's not the final functionality, but we'll change this in a moment. Let's say user. No, it's actually Spring. So Spring security user password. Here with this, we can really set our password for Spring security to something that we always reference. This is really just for test purposes and won't have any impact on the production side. At least if we properly remove this again. So we really just keep this for test purposes. We run our backend and then let's go to Postman once more. Sorry, there was a bit back and forth here, but we swap this out with a test. Then we also don't need to get back to this authorization tab anymore, since the test password will now always be the same. We go to body. Now we don't need the owner ID anymore, but if we click send, yes, we did get an okay response. And it responded with more JSON, specifically the node ID that was created here, the title, the content, the color, and when it was created in a timestamp format. So you can see that was a lot of back and forth, but I really think this still helps if you're new to REST APIs, that you understand what could be the reason if something like this goes wrong, if you receive 401 for a test backend, if you suddenly receive 400 bad requests, what that means, because you really need to understand these very common status codes in order to see, okay, 400 bad requests means I send an invalid request. So that always hints towards some kind of request parameter that you should have provided but didn't, some kind of parameter in the JSON structure that is not optional that you did not provide. It could be that you misspelled one of these parameters in the JSON, then we will also get bad request. So the Kotlin variable names in the data class for the node request must exactly match the JSON field names. But there is still one interesting thing that we need to check left. And that is if our node that we pushed here via our client is actually really saved in our MongoDB database. And well, that is something we can check here in our browser. So I want to close this connection dialog again, but we now have our cluster and we can then go to clusters here under database. We click on our cluster and then there is this collections tab, which actually just lists all of our collections of our database. And you can see there's our nodes collection in our nodes database with our nodes document. So this is really how MongoDB really now stores our data persistently here in our cloud database. You can see there's also some information about the specific class this can be parsed into. But this now means if you see this document here, that your node was really saved. And we can also try this now by taking the owner ID, copying that, going to Postman again, making this a GET request. And here we say we want to fetch the nodes for the owner ID, which we paste now. If we send this, then we do get a list. So these angle brackets are these square brackets with all the node documents that belong to this owner that we've provided. So that's working perfectly fine. If we provide an invalid ID here, like swap this out with a 3 here, then we get an empty list because this owner has no IDs. Okay, but what might still be confusing to you is how all that works. Because in the end, in our code, we've declared a lot of objects. Like we have this REST controller, we've passed this node repository, we now have the security config with configuration and bean, whatever that may be. But somehow everything is automatically wired together, because normally in Kotlin, the moment we declare a class, then this class doesn't do anything unless we explicitly create an instance of it. And if we create an instance of it, we would also need to create an instance of this node repository here that we can then pass to the constructor of this one. Same thing for the security config. This filter chain function is somehow called without us needing to do this on our own, without us needing to create an instance of security config. Well, and that is one of the core ideas of Spring Boot. All those classes that we annotate with a Spring Boot or Spring specific annotation, like configuration. You can see this comes from the Spring framework. With Bean, Spring framework. REST controller, that also comes from the Spring framework, so lots of different annotations. All those classes annotated with these Spring specific annotations are actually managed by the Spring Boot framework. So we really don't need to care about constructing these objects. The moment we annotate these with an annotation that Spring Boot knows how to deal with, it will construct these objects in the right order. Same for the node repository. This is actually not annotated with a Spring specific annotation, but it is a Spring Boot repository, which the Mongo repository is under the hood, which is also automatically created by Spring Boot and also managed by it. And all these classes that Spring Boot manages, we can freely pass to other classes by just passing them here to the constructor. And that's in the end also what a bean is. So that's not related to Mr. Bean, but it's in the end really just a component and an object, an instance of a class that Spring Boot manages for us. And this is actually super helpful because on the one hand, what Spring Boot can do is it can give our beans specific functionality related to just global server related functionality, like we can easily log something in our server console, but it also allows us to automatically inject these dependencies somewhere. So dependency injection is a very common software development practice that we take one dependency, so an instance of a class that another class could depend on, and inject that, so pass it to another class, which is exactly what we do here. That we have a dependency, we pass to the constructor of another class. That's dependency injection. So this is just really, really important to understand that you don't have to do anything with these objects here on your own. You just need to tell Spring Boot what type of object a specific class is, and Spring Boot will do the rest as long as you conform to the rules. So for example, have functions in here annotated with post mapping, annotate the request body properly, annotate request parameters properly, and so on. So that was a lot of testing and a lot of understanding how Spring Boot works, but it's really important to understand how everything works together here if you really want to build custom backends as well, and not just a copy of the one that we built here. So let's do one last thing for this node controller before we move on, and that is to provide one more mapping which is used to delete nodes again, because that's something we don't do right now. So here, that's pretty easy now. We really just want to provide a delete mapping. And here we also need to, of course, pass the parameter of the node that we need to delete. For both get requests and delete requests, these parameters are typically in the URL, while for post and put requests, they are in the body. Not always, but typically. So typically get and delete requests don't have a body. These are also often ignored by such backend frameworks. But we can say delete by ID. And here for the delete mapping specifically, since we need to pass a specific node ID that we want to delete, we say we give this another relative path by saying path is equal to new string. Actually, that must be an array. So we say an array of slash and then curly braces ID. And if we then go in here and say path variable ID, make sure to call it the same, and then open this code and call repository.delete by ID, we say object ID with our ID. What this now means is we have a path variable. So on the one hand, we have query parameters, which is the one that we've used before. So here, this would be a query parameter, which we explicitly specify based on its name here in the URL. If we would have multiple of these, then we would say and something else, other parameter is other value. So these query parameters always come at the end of the URL, started with a question mark. But on the other hand, we also have path parameters. So if we want to delete a specific node, a good URL structure would be that if we have a delete request now, this is not being made to nodes with the node ID, for example. That would also work. There is nothing that prevents us from doing this. But to be really on the safe side that this request can only be made to a URL where there is a valid node ID, especially if we have such endpoints like here, we instead want to make it to this URL. So delete request will only be valid if it's actually made to our nodes endpoint with a specific node ID that is part of the URL without really naming it. So if we take this, then we just say, hey, that's the structure. We expect an ID parameter as a path variable, and the ID parameter we then get here in the function, so we can delete the right node in our repository. If we rerun this and go back to Postman, then here Mongo Atlas, that's important actually as well, that we need to take this node ID we now want to delete. So we take this and also click cancel here. We go to Postman, and this time I want to make a delete request where we say we want to delete nodes / and then we paste our nodes ID. So this particular node we want to delete. It doesn't matter if we attach a body that is by default ignored. Just make sure you again have this valid authentication. If we hit send, we do get an OK response, no body, because as long as the client sees OK that responded with 200 OK, then the deletion was apparently successful. And if we now go to Mongo Atlas and we hit refresh somewhere up here, refresh, then suddenly our document is gone because we've deleted it. So that also works perfectly fine, and that's already the vast majority of logic for this node controller. Of course, as I said, a very important thing to consider here later on is to automatically somehow retrieve this owner ID information about the user who made the request, so the user can't tell the server who made the request. The server needs somehow a secure way to infer the user without the user being able to change that information. So let's get to the auth mechanism next, and that will actually be the more complex part of this course. So in order to be able to authenticate a clear user, the first thing we of course need is a user. We need to tell our server, we need to model what a user actually is in the context, in the scope of our project. So that means we of course need to somehow allow users to register a new account. And this new account, this user model, we then need to save in a separate collection as a document in our MongoDB instance. So in our database model, we want to create a new Kotlin class called user, and we make that a data class. And this will really have the exact same structure, just like the node class, just that we now store user-related fields. So on the one hand, a user has a specific ID, of type object ID again, which we annotate with Alt-Enter to import that. And we can default initialize this with = object ID. A user also has an email address, and a user has a password. So we obviously need to somehow store the user's credentials in order to then later on compare that with what the user has entered client-side in the mobile app, for example, to see, okay, was that the correct email together with the correct password. However, what's really, really important in regards to security here when you store such sensitive data is that you better don't. Because even though only we have access to our MongoDB instance, so nobody else should be able to read all these user documents in our users collection with their corresponding passwords, that is still something that occasionally happens in the real world, so that certain databases are leaked, that backend environments are hacked, and then you definitely don't want to have all your users' passwords being saved in plain text, so the attackers could just go ahead and use all these credential combinations to log in with their users' accounts and do whatever they want with it. So instead, what is the typical practice is that we don't store the password as plain text, but as a hashed version. So we have a hashed password. What hashing means is, hashing is pretty much just a one-way function that takes a certain input, like a password, for example, and that always transforms the same input into the same output, but with the output, with the so-called hash, we can't easily reverse that. So we can't easily extract the password again. So for example, we have our hash function that takes in a password hello, but for the same password, it will always result in the same gibberish. However, if we have this gibberish, we can extract the password back out of that gibberish. That's exactly how such a hashing function works. Because if the user now sends this password hello to our backend environment via HTTPS, so an encrypted connection, then we of course retrieve the password here in plain text after it being decrypted. Then we hash it. So we save this gibberish here in our database for the hashed password field. But because the same password always results in the same gibberish, if the user enters the same password, then we can hash it again and just compare the gibberish with the hashed version of the password the user has entered. And if the gibberish matches, then we know the user entered the correct password. So that's really the typical approach how you save such sensitive data that is really only meant to be compared with values. So for a password, we don't really need to know whether the saved password is actually the plain text equivalent to what the user entered. We just need to know, is it the same password? And that is something we can also detect with the hash. So I hope this made sense. We need to annotate the document with document again. Document with parentheses, and we call this the users collection, and we alt enter on document so we can import that. And that's really everything we need to save for a particular user. Of course, if you would have an app or a website with real user profiles, like a social media app, then you would save more information for such a user document, like a profile picture, URL, and so on. But we're fine with just that information. The next step is that we also need to define a repository for users. So we go ahead and say user repository. That is an interface. We make this implement the Mongo repository interface, which stores documents of type user. We also identify a user via an object ID. Now we again need to ask ourselves if there are any special queries we might need to define here in order to query a specific user, for example. And yes, there is. We do need a query to check if there is an existing user for a given email. So when a user actually tries to log in with their credentials, they enter an email and a password combination. And then we, of course, need to first of all check, is there an existing user account? We need to find the user, and we need to be able to retrieve the hashed version of that user's password if that account actually exists in order to compare that with the password the user has entered. And that's exactly what we need here. So find by email, we pass in the email, and the result is simply a nullable user document. So we pass in the email that the user entered during login. This will try to find a user document via this email and then return that. And if there is no user with that email, it'll return null. All right, as a next step, before we get to the real authentication mechanism, let's be able to take an incoming password from the user and store it as such a hash, or rather just be able to hash it in the first place. And that is something I want to do here in a separate class in the security package, which we call password encoder, for example, password encoder, or maybe a bit more generic to call it hash encoder. This can be a class. And in here, we will create an object called bcrypt. So bcrypt is a library that we have also already added, which comes from Spring Security as well. So just like what we specified here from the security config. So really that part of Spring Boot that is responsible for everything security related. So here in our hash encoder, we want to create this bcrypt object, which contains the entire hashing functionality. And that's really what I can also just recommend you to not implement that by yourself. Especially anything that is security related, you better don't implement on your own, because there were already people who put a lot of thought into this to really protect these algorithms, because already small issues in these cryptographic algorithms can make attackers break them. So please make use of such established libraries like bcrypt. So I want to set this to a bcrypt password encoder, and then we simply expose a function to encode a raw string, which then returns us the hashed version of that string. And we set this simply to bcrypt.encode, and we pass in our raw string. And the rest our tool bcrypt will then do. On the other hand, what we need is we need a function whether a raw string, which will be the password the user enters during login, actually matches an encoded version of that string, or we could also say a hashed version. Oops, a hashed version. And this will then return a boolean whether that matches by saying bcrypt.matches raw and hashed. So the hashed string will then be the password that we've saved for a particular user, the hashed version, and the raw will be the new password the user has entered during login. We will then, or the tool actually then hashes this again, compares it with the hashed variant, and checks if it's actually the same. And if this would return true, then that means the user would have entered the correct email password combination. And what we want to do is we want to annotate this class with add component. That's another annotation that's new here, but it's really just a more general annotation from Spring Boot that marks this class as a component. So as an instance that is managed by the Spring Boot framework after all. So we don't need to instantiate that on our own, but the moment we annotate it with component, we are able to inject this instance in other classes, for example, which will automatically be done by Spring Boot. And by the way, I'm not sure if this is a feature of IntelliJ Ultimate or also in the community edition, but here we also have these bean definitions where we can see this beans dependencies diagram, which is sometimes really useful to see how all these different class instances, all these different beans in Spring Boot actually depend on each other, which one is used for which one. You can see the node controller actually depends on the node repository, because in the node controller, we are passing this node repository. So this dependencies diagram is sometimes really, really useful, especially if you are constructing some larger architectures for your backend. All right, so let's get to the more juicy stuff here. Let's think about, first of all, how we really want to implement authentication, because there are lots and lots of different authentication mechanisms, how we could really identify a user who makes a request, a client who makes a request. And the approach that I will choose here is typical JWT session-based authentication. So it sounds super complex, especially if you're new to this, but let's take a look at JSONWebTokens.io. That is a little sandbox website that explains how these so-called JWT tokens work. So that stands for JSON Web Token. And the special thing about this type of token is that the tokens are stored client-side. So either in the mobile app, in your browser, but it's not the server that keeps these session tokens. And a token is really just something like this here. So just a sequence of some kind of characters and numbers. But the cool thing about JWT tokens is that we can encode information about them. So especially if we go to the decoded payload here and click on JSON, then you can see we have a subject, a name, an admin boolean here in this case, and an IAT, issued at. So all this is currently information that is stored in this specific token string. And you would notice if we actually go to the JWT encoder, so here this decoder is used to paste in an existing JWT token and read this data that is saved in there. If we go to the encoder, it's the other way around. So we can enter the data we want to save on this token, for example, the subject. That's typically some kind of identifier about who owns this token. So in our case, for example, the user ID. And additionally, we can save some more optional data like the name of the user. But the moment we change this, and we change this to Jane Doe, for example, you just saw on the right side that the middle part of the token changed. So this token, as you can see, actually consists of three parts: this green one, the white one, and this blue purplish one. And on the left, we can see what each type actually represents. So here, the first part, so the green one, just declares the algorithm with which this token is generated and what kind of type of token it is. Here, it's just a JSON Web Token. Then the middle part is the actual payload. So the real data we want to encode in this token, we want to save there. And lastly, the blue one here is the secret. This must be just some kind of string that must be secret, that must always stay the same for all of your tokens, and must also only be kept server-side, so nobody should really get the secret. But what's so cool about JSON Web Tokens is that we can save data in these tokens, but we can detect if the client mutate that data. Because obviously, if we store such session tokens client-side in the local persistent storage of a mobile device or of the browser, then we of course can't be sure anymore that these clients actually change these values, because yes, the client device could of course also implement this decoding logic in order to read this data here and then say, hey, I'm actually not user 123 blah blah blah, I'm actually a different user. But the moment that happens, the moment a client actually mutates, for example, the user ID here, and says, I am actually this user, then a big part of the token actually changes. And this is something we can detect server-side. And we could then say, hey, that is not the token that belongs to you, so we won't grant access to you. But still, at the same time, if the client does not mutate the token, and we would be able to detect, yes, that is the correct token for the correct user, then the user ID of the owner of that token, so the user ID of the user that has successfully logged in, is included in the token, so we can grab that server side for each and every request that is made with this token and automatically know who made that request. And that is super useful. For example, if a client wants to retrieve their own nodes, so if we have a logged in user, the logged in user has a saved token which is attached to a request, for example, the GET request here in our node controller, this one here, then if a token is attached, we can retrieve the token here server side. We can read the user ID out of that token, and then we automatically know who made that request, and we can fetch the nodes for that without the client explicitly needing to provide some kind of a URL parameter or so with their own user ID. That is the whole idea of JWT tokens. And this functionality, in order to be able to generate such tokens, and on the other hand also validate these incoming tokens from clients, whether these are correct or whether they have been mutated in some way, that is what I want to do in a separate class called JWT service. So here in security, we create a JWT service. A service is in the end just a class that is mainly intended to provide functionality to other classes, so one that exposes functions and does not strictly keep any internal state or so. And we can annotate this with service. Service is another annotation, but if we actually command click into that, we see that a service is nothing else than the component annotation we've also used for our hash encoder. So it's really only for semantic reasons to be a bit more specific, but under the hood, it's treated exactly the same as a class annotated with a component. Okay, so as I said, every single JWT token needs a secret in order to be signed. And because we keep that secret on the server side and clients don't know that, they won't be able to issue their own JWT tokens in order to kind of fake a valid token. That won't be possible unless they have access to the secret. That is why it's important to keep it secret. So we first of all want to create a secret key that is used to sign these tokens or to generate these. This can be created with keys.hmac SHA key 4, so that's just the cryptographic algorithm. And here we need to pass in the key as a byte array, which is also a very good candidate in order to put that into our environment variables, because we don't want to have this secret here as plain text in our source code, which would then get pushed to GitHub, for example. And typically it's even better if we use the base 64 encoded version of that secret as an environment variable, since that's not immediately readable. We could reverse that if we would really want that secret, but it's just meant to not show the plain text secret if maybe your colleague is looking over your shoulders or so, and they shouldn't be able to access that secret. So we could go to our browser, new website, base 64 encoder, just an online encoder here, this one for example. And here we can just paste our actual secret that we want to have here. Could just be any randomized string. This really doesn't matter as long as you always use the same one for generating the same type of token. So if we then hit encode, this is the base 64 version of that string, which we can now copy, go back to here in our environment variables, edit configurations, click on this little paper icon, and now we want to create a JWT secret. And here we paste the base 64 encoded version. We maybe also want to say that's the base 64 encoded version, so people aren't confused if they try to use this directly without decoding it first. So we can copy this name, click OK, and there's no cool way in Spring Boot to directly reference such variables here in our code. So first of all, what we need to do is we need to add this here to our application properties file. So we want to say we have a JWT.secret and we reference our JWT secret base 64 here. And then in our code, in our JWT service here in the constructor, we can reference the secret, so JWT secret, which is a string. We can reference this with value. So with the value annotation, we can retrieve a specific value, specifically this one here, from our application properties file. And Spring Boot will again automatically inject this right value here at runtime into this JWT service, so we can use it here for generating this secret key. So here we don't want to just say secret to byte array or so, but that's the base 64 encoded version. So we want to say base 64 from Java dot get decoder in order to decode our encoded token. And we say dot decode and we paste in our secret. And that's it. That is how we create the secret key in order to sign our tokens with it. And now something that I haven't told you yet is that we will actually need two types of tokens here per user. On the one hand, there are so-called access tokens and so-called refresh tokens. So an access token is actually the real token that grants the real access to our backend. But it's typically a very short-lived token. So we obviously want to give our tokens validity, so a specific time when they expire, and wouldn't grant authentication access anymore, because it would be quite bad if maybe an attacker gets access to the local token of a mobile app, of a browser or so, and then they would have just indefinite access with a token to always make authenticated requests. But this way we can actually put some kind of timer on them that they only have limited access of a specific token. On the other hand, we then need a longer-lived refresh token. So the access token validity is typically around an hour maybe, or 15 minutes, something very short. The refresh token has a longer validity of, let's say, 1 or 2 weeks. And only with the refresh token, a client is able to refresh their access token. So when their short-lived access token actually expires, then the client will still have access to that refresh token in order to refresh their access token automatically in the background, so they keep that authenticated access without requiring the user to relog in. Once the refresh token, so the longer-lived token, expires, that would mean the user could only get these authentication privileges again by relogging in, since only after a valid login the user gets issued a refresh token for a specific amount of time. And depending on what kind of app you're building, you of course need to adjust the validity of these refresh tokens to that. Some apps also don't use a validity or an expiry date for refresh tokens at all, so you never need to relog in. But that would also, of course, be rather not so secure, since an attacker could, of course, also use this refresh token in order to get a new short-lived access token that grants access to the API. If you, however, build something like a banking app, for example, then you want that the user regularly relogs in with their credentials, so that even a leaked refresh token wouldn't give an attacker much power or much time to do something with that. So we want to have a private val access token validity milliseconds. And let's say in our case, we're building a Node app. We make that's the access token. Let's say here we make the access token valid for 15 minutes. So 15 multiplied by 60 minutes multiplied by 1000 milliseconds. So here we have 1 second, 60 seconds, 15 minutes. And the same we do for the refresh token. This one is public because we will need this in another class as well. So refresh token validity milliseconds. And here, let's say we make this valid for 30 days. So 30 multiplied by 24 hours multiplied by 60 minutes multiplied by 60 seconds multiplied by 1000. So we have 1 second, 1 minute, 1 hour, 24 hours, 30 days. And then here we can have a private function to just generate a token, generate token. And I think I will actually turn off this AI autocomplete because I think this rather confuses us here than does it help. Okay, so what do we need in order to generate a specific token? We do need a user ID, since that is the information we need to include in our tokens. We do need a type, which is of type string, and we need an expiry, so our milliseconds in which or for how long it will actually expire. This will then return a string, so the final generated token. And here we can generate the token with JWTs.builder. And here we can now configure how our token should be generated with this JWT library that we're using. So first of all, the subject, so who owns this token, should be set to our user ID. Then we do want to include the claim type. And we say, hey, we also want to include the type of the token here. We say the token is issued at, here we could actually store this in a now field. So if we just say we set this equal to a new date, then this is the current date that refers to when we call this function. On the other hand, we want to create an expiry date, which is equal to a date that takes the time from now plus the expiry. So we can say issued at now, expires or expiration, expiry date. And then lastly, you want to say we want to sign this token with our cryptographic key we have referenced before. So our secret key, and we need to specify the algorithm, which is JWTs.signature.hs256. And then we just need to call compact, which will really take all this information and package this into a JSON web token. Because with this generate token function, we can now expose two functions. On the one hand, a function to generate an access token, for a specific user ID, which will give us the token as a string. So we can say return generate token, pass in the user ID. The type of this one can be access, and the expiry will be our access token validity milliseconds. And the same thing we then do for the refresh token. So generate refresh token. For a specific user ID, we call our generate token function. This one is a refresh token, and we reference the refresh token validity milliseconds. Okay, so the whole procedure will now be the user registers. That is what really creates such a user document here in our database with their hash password. If the user then logs in with their credentials, with a valid password, with a valid email, what our server will do is it will, first of all, go to the JWT service. It will generate a refresh token for that user and actually also an access token. So just a token pair that is generated for a specific user who owns this token pair. The server will then respond with that token pair to that successful login request. The client stores these two tokens in their local preferences. For every request made from then, so to fetch the specific nodes for that valid authenticated user, the client will then attach the access token. And once the server says, okay, that access token was actually invalid or it expired or so, then the client takes the refresh token again, which is in their local preferences, and calls a specific refresh endpoint that we will still have to implement in order to get a new refresh token. So the whole procedure is now that the moment a client registers, we just create a new document here in our user collection. And if the user then logs in with their valid email and password combination, what our server will do is it will use this JWT service. It will call this generate token function to generate a pair of tokens, an access and a refresh token. This token pair is then responded to the client after this successful login. The client then stores both these tokens in their local preferences, so just persistently. For every single request that is authenticated from that point on, like retrieving nodes for that specific user, the client will then attach the access token as a specific HTTP header, which I will show you in a moment. And once the server says, no, that access token you attached in order to retrieve nodes, for example, is invalid or it expired, for example, then the client will take their locally saved refresh token, which they can use to request another specific endpoint we still have to implement in order to get a new access token thanks to their longer-lived refresh token. If that endpoint also says, no, with that refresh token you actually can't log in, that's invalid because the refresh token might have expired, then the client will have to sign out the user and ask for re-authentication in order to just get a new refresh token. That is really the whole auth flow here. I know, especially if you're new to all this, this is very complex. You just have to go through this once or twice, maybe implement this whole thing on your own, work with that on a client device in order to really truly understand this authentication mechanism, but it's a really good one. So we now need functions here, server-side, in order to take such an incoming token from the client and validate it. So the client makes a request to our nodes endpoint in order to fetch their own nodes. So we need to now have a function that says, yes, you are allowed to retrieve these nodes, or no, you are not. So we say validate access token. We pass in the token here, and this will simply return a Boolean whether that token is valid. And now a little helper function we need for that is a function that parses all those token claims, so all the data that we saved in a token. We again pass in the token. This will give us claims. So from JSON Web Tokens, a claims object, nullable. And here we could then say return try. In case something goes wrong here, we simply return null. But in the try block, we want to say JWTs.parse at this time. So we want to parse a token in order to understand its claims. So the data is saved in there. We want to verify this with a specific secret key that we've attached here. We then call that build. We call that parse signed claims of this specific token and then reference this payload. So what effectively happens here is this is the token that the client would have attached. Then we first of all want to parse this token. We say, okay, this must be parsed with our secret key. If this now fails, that would mean that the user actually changed some parts about the token. And that would be the place where we detect the server side, where we would be like, okay, bro, you actually changed the user ID. This is not the real token that we issued you. And that would be the place where we say, you know what? You are not allowed to access that node endpoint. However, if after verifying this with our secret key, if that results in the correct claims, if that really gives us valid data for these claims, then we simply return that data here in order to get, for example, the user ID out of that token that the user has attached to the request. So here in validate access token, we can say we get the claims by saying parse all claims for this token If the claims are null, so that means something here crashed, it couldn't parse the claims or so it went into this catch block, then we simply say we return false, because then the token is definitely not valid. Then we can retrieve the token type, so the type that we've previously attached here via a normal custom claim. So the subject is really just what includes the owner information of the token. And with claim, we can just really attach additional data to this token. So the token type here would be token, claims. Here at the key of type, we try to parse that into a string. If that's not parsable, we also want to say return false, because then it's an invalid type. It was mutated again. And then we return whether that token type is actually equal to access, because then we have a valid access token. The same thing we now want to do for refresh tokens. So we have a function to validate a refresh token. And here we really do exactly the same, just that we check whether the token type is actually refresh. But parsing the claims works exactly the same, since we use the same type of token. And one more function we need, and then we're done with this JWT service, but not yet with authentication. There's still a bit to do. One more function we need is, in order to really work with these tokens, to be able to get the user ID from a token. So we pass in the token, and we then retrieve, or we then return the user ID as a string. Because this function is now needed that for incoming requests for authenticated endpoints, like retrieving all nodes for a user, that we can take the incoming token, retrieve the user ID to then say, okay, let's query all nodes from this specific owner ID. So in here, we can say val raw token, because this token might not just be the raw token, but might be the exact content of the header, since the way the client needs to attach the token to the request is via an authorization header, and that looks like this. We have authorization, that is a type of header, and then we specify that this is a bearer token. That's just the name of these types of tokens, and here comes the actual token. So this part will be the type of header, which is not relevant here for this function, but everything that comes afterwards, including this bearer word, that is part, that could be part at least, of this token that we pass here. So we first of all want to make sure that we cut off this bearer in order to just be able to retrieve the raw token. That is what we do right here. So if the token that starts with this bearer keyword and a space character, then we say token.remove prefix, and we remove exactly that prefix. Don't forget about this space. And otherwise, if we already attached the raw token, then we just leave it unchanged. Because then we can say we have our claims that we can again take from that raw token. So we pass this in here. If this is not existent, we can throw an illegal argument exception where we say invalid token. And then we can say we should simply return our claims.subject, because the subject is what contains our user ID, since that's what we've passed here. The next thing that we now need after having this JWT related functionality is a so-called auth filter or request filter. So request filter is in the end just a piece of functionality that gets executed for every single request that has a specific job. In our case, that would be at least every single request that should be authenticated. So in our case, our node routes, we need to execute code that checks and validates the token to see if the user is actually authenticated. And that is something we can do here also in security by saying we create a JWT auth filter. Let's call it like that. This is now not a service anymore, but simply a component. So Spring will manage creating and injecting this component. And here we can then say we do need access to our JWT service, since in order to validate a token, this service is what has the functionality for that. And this is not just a normal class, but a so-called once per request filter. So that is a parent class we can make use of here in order to be on the safe side that this filter is definitely only called once per request, so we don't validate a token multiple times for one single request. We then also need to override the do filter internal function, which really applies this filter. So we get information about the request, about the response, and then the filter chain. So there might be multiple independent filters, which we can then say, okay, our filter is done, let's proceed with the next filter. So here we can then say we have our auth header, so header part that I just mentioned, where the token is actually stored in, that's equal to request.get header, and we want to get the authorization header. So that's always the header that contains the authentication information. So this auth header might now be in the format bearer, and here we then get our actual token string. So same thing as before. So I think this point, it might actually make sense if we jump back to our JWT service and we also parse this raw token here also in our validation functions. So I think it would just make sense to take this raw token code and move it into this parse all claims function, since this is the function that we use across all these here. So we don't need to duplicate this code. So we can just cut this off, say we put this in here, get the raw token out of this token that we've passed, make sure to parse the signed claims of this raw token now, and then our other functions become a bit simpler, since here we can just pass in our token and here as well. So these validation functions would now also work if we pass in the header with the bearer keyword as well, or if we just pass in the raw token directly. So here for the JWT auth filter, we now get this header and we can check if there is actually an auth header. So if that's not equal to null, and the auth header actually starts with bearer, because only then we know that this is the token type that we want here, that we care about. Because there are also different types of authentication, like basic authentication. That is what we used here for this test environment, where we had to provide here a username password combination just in order to be able to authenticate with our REST API. So this is now independent of the actual user accounts here on our backend. But there's also authentication in form of maybe API keys or so, where you have a specific sequence of characters that authenticates you. But here with tokens, we are actually able to store information, which is why these are super useful. So if we know that we are dealing with the right token type, we can now check if JWT service that validate access token, since the token that is contained here in this authorization header is always the token that should also authenticate the user, so the access token. If we validate this token now with auth header, then not do this in here, but just open a block of code. Then we want to retrieve the user ID on the one hand, which we can do with JWT service, get user ID from token, and also pass in our auth header. And then what we can now do with this is we can change the so-called global security context of Spring Boot. So that's just a kind of a global object that allows us to retrieve the authentication information of a specific user anywhere in our project, in any controller, for example. So we can say val auth is equal to security context holder that get context, and we set the authentication object actually to something we create before. I was actually in the wrong line. Let's put this in a separate line and set the auth object here to a username password authentication token. For the principal, that is our user ID. So this could be anything. We don't have any specific credentials here, since we're just storing a token that is already that already includes authentication information. And then we can use our security context holder and set the global authentication object to this username password authentication token. So this is really just a utility for us to retrieve this auth object here technically across the code base. But after this if chain here, we can then say filter chain dot do filter. So this will really just forward or just make the next filter execute. So we pass in our request and response. And then this is already it for this JWT auth filter. So now we have really everything that we need in order to work with our tokens. The only little bit bigger thing that is now missing is that we are actually able to really register new users, to store new user accounts, to really hash their passwords, to make sure that if a specific client calls our login endpoint, that we also really validate the credentials and so on. So this is the last bigger thing that's now missing in order to have a fully working backend. And for that functionality, I also want to create a service class like this JWT service, where we can say, hey, let's just also put this in security and make this an auth service. So auth service annotated with service. And this will now need multiple things. On the one hand, we do need our JWT service in order to just generate a JWT token when a user logs in. What we also do need is we need the user repository in order to just save new users in our database when they want to register. And we do need our, not password encoder, but it is our hash encoder, we call it. Hash encoder here. And here we really then just provide the functionality to, for example, register a user via an email, via a password, and we then return the final user object as it just is saved in our database. So here we can really just say user repository, want to save a new user, and that user is a new user object, where we say the email is equal to our email. The hashed password is now not the password, that's the plain text password here that the user entered during registration. But we want to save the hashed variant of that, so we say hash encoder.encode, and we pass in our password. And that way we really just save something and an attacker couldn't do anything with if they would get our access to our database in some way. And that's already our registration function. We simply take the user's new credentials and we save this in a database. In a real world environment, you would of course maybe send a confirmation email or so people couldn't spam you with new account requests. But for this simplified backend, this will be totally fine. We then want to have a function to log in a user with an email and a password combination. So email, password, and this login should now not return a user object, but actually a token pair. So just a pair of access and refresh token that we then need to send back to the client in order to just store it on the client side then to attach these tokens to the requests. So access token for the authenticated requests and refresh token for getting a new access token once the old one expired. For that, we can also create a little data class in here to tell our code what a token pair actually is, because that's really just a pair of access token and refresh token. That's really it. Just a class that bundles these a little bit. So when a user wants to log in with an email and a password combination, what is actually the procedure? What do we need to check here? First of all, we want to check if that user actually exists. So we're going to say val user is equal to user repository, find the user by email, we pass in the email, and if this is not existent, so if this returns null, that means there is no user who registered with that email before, then we can throw bad credentials exception, which comes from Spring Boot, where we say, okay, invalid credentials. And that's, by the way, also a little best practice that you should rather not say something or rather not throw something like, this email doesn't exist, which we could of course do. But if this is really an error message that the client could see, then they could use this information in order to kind of query your backend server in order to just throw in some emails and see if that user with that email actually has an account. So they can really get information from such error messages. That is why if a login fails, we typically just want to say invalid credentials, because invalid credentials could be that there is a valid email, but the password is simply incorrect, or that the account doesn't exist in the first place. So right now, if the code reaches this point, we know there is a user with that email. What we don't yet know is that the password is actually the right password for that user. So that's the next thing we need to check. So if password hash encoder matches, so our raw password with the user's hash password from the database, if that does not match, then we again throw a bad credentials exception, because this would now mean the user has a valid account. So the email, there's definitely an account under that email, but the user entered the wrong password, since the hashed version of the password the user has written does not match the hashed version of that user that we have in our database. However, if our code reaches this point here and did not throw before, that means the user entered valid credentials. So what we now want to do is we want to generate such a token pair and respond with that. So we get the new access token, which is equal to JWT service, generate access token for the user with the user ID, 2 hex string, and we want to have a new refresh token, because after a login, we also want to generate a refresh token for that user. So we say JWT service, generate a refresh token, and again, user ID to hex string. And well, what we could now do is we could say we return a token pair where we say, okay, our access token is the new access token. The new refresh token is the new refresh token. That is what we would then, actually the refresh token is our new refresh token, which is actually the information that we need client side. So this is completely correct here. But no, so if the access token at some point expires, which happens, I think after 15 minutes or so, what did we set here? 15 minutes, yes. So if the access token expires and the client wants to request a new access token via their refresh token, what they will then do is they will call a dedicated refresh endpoint, passing their locally saved refresh token to that request. And the server then needs to validate whether that refresh token is of course valid and whether the user should be able to refresh the token. But how can the server know that, whether that refresh token is actually the one for that user, if we don't save that as well? We need to save the refresh token in some way in our database again. So that's why we need a separate model here just for our refresh token collection. So we create a refresh token collection, make this a data class, annotate this with a document, alt-enter to import document, and we call this refresh tokens. And this is now the collection of documents in which you save all refresh tokens from all users. So specifically, we want to save the user ID, which is an object ID. So that is the ID of the owner of that refresh token. We do want to save an expires at instance, so when this refresh token expires. And we maybe want to save a created at timestamp, also in form of an instant, which we can set to instant.now as a default parameter, just because this information is sometimes pretty useful. And of course, we do need to save the token itself. So you might now want to go ahead and say, well, token as a string, and you save this in your DB. But here we actually have the same problem as we have for passwords that we save in our DB. If our DB for some reason gets compromised, then an attacker could normally just see all the plain text refresh tokens they could then use in order to refresh an access token and again get access to our authenticated API for a specific user. Not what we want. So instead of saving the raw token, we also want to store a hashed version of that token. So hashed token. Because here we have the same scenario that we don't really care about reading the token string of an already saved refresh token, but we just care about comparing the refresh token the user has attached with the one that we've previously saved. And for that, a hash is completely enough. And another very cool hack that we can apply here from MongoDB is that we can take this expire_as field and we annotate it with @indexed. Here, make sure to use the import from MongoDB. And we set this to expire after 0 seconds. What does that do? So a database index on its own is really just kind of a separate list managed by MongoDB that just allows faster database access, faster database queries. Specifically, MongoDB typically keeps these index fields in a separate sorted list because finding a specific element in a sorted list is way faster than finding an element in a not sorted list. Since if a list is sorted, we can apply an algorithm called binary search, which is super efficient, super fast, and therefore allows faster queries overall. And a cool thing that we can now do with MongoDB is that we can index this expire_as field so that MongoDB kind of keeps track of all these field values of all refresh tokens. And if we save an actual instant in there and we say expire after 0 seconds, then that will have the behavior that the moment this expires_at date is actually met. So the moment our refresh token should actually expire, MongoDB will just periodically check for all those expired fields and delete these when they expire. So they don't just stay in our database and occupying space. So we don't really need to remember deleting these on our own. And just like for our other database models, database documents, we also need a way to interact with the new collection for refresh tokens via a repository. So we do create this repository here by saying refresh token repository, make it an interface. At this point, that's nothing new to you. Mongo repository, we want to store refresh token documents and they are identified via an object ID. So here I've actually omitted this ID of the refresh token itself. It will still get one, but we don't care about what that is. So we don't need it here in our code, but that's still identified via that standard ID from MongoDB. So now we need two functions here in order to interact with this refresh token repository. On the one hand, we want to be able to find a token that has a specific user ID and token combination. Because the scenario is now this, that a user wants to refresh their local access token. They attach an existing refresh token we at this point should already have in our database. And we then just want to check if the token, the refresh token the user has attached, really belongs to the user ID that they claim to be. So here in our repository, we can say function find by user ID. And what we can do now is and hashed token. So this is how we can chain such fields to find documents where both these things actually must be true. So where the user ID must match and where the hashed token must also match. And then we return the refresh token nullable. On the other hand, we want to have a function to delete a token by user ID and token hash, or hashed token again. Hashed token like this, and same thing here. Because it could be that there is still a document here in our refresh token collection that is still technically valid, but if the same user that has this saved refresh token relogs in before the previous refresh token expires, we just want to make sure that we delete the old reference. So back to our auth service, what we now need is a way. On the one hand, we need access to our refresh token repository. And now we need a way to just store a new refresh token document in there. Since we need this in multiple functions in here, we can make this private function store refresh token, which takes in, user ID as an object ID, and it takes in the raw refresh token. So that is the non-hashed version. And then we can say, the hashed variant of that is our hash encoder that encode, pass in our raw refresh token. Since for passwords, we even need more security than for such refresh tokens, because the thing is, passwords are human chosen and therefore they are not completely random. And bcrypt will just apply certain extra security measures to hashed passwords that make it much, much harder and much, much more CPU intensive for an attacker to guess certain passwords, because there are certain lists of the most common types of passwords online. An attacker could now, of course, go ahead, even if they just have a hashed version of all the user passwords, but they could just try all the most common passwords and certainly find some passwords in a big database that match, because the hash is, again, the same. So bcrypt will actually just hash the same string multiple times, will apply some unique random generated salts, that is what we call that. That's really nothing we need for refresh tokens, which are already random by nature and not human chosen. So it's super hard to guess the refresh token here, which is why a simple, more efficient hashing algorithm is actually enough here for the refresh tokens. So let's just declare this here, get rid of that for a moment. Private function hash token, we pass in our token, and then we return the hashed string. And for that, Java also has its own toolkit. It's called message digest. So we set this to message digest.getInstance, message digest.get, I think I imported the wrong one. Message digest, this one here from Java security, get instance. The algorithm is SHA-256. And then we can get the hash bytes via saying digest.digest. We pass in the string that we actually want to hash. So token, encode to byte array. And then lastly, we can return base 64 again. So we additionally encode this with base 64. We say get encoder this time, that encode, and we pass in our hash bytes and actually encode to string, since that is what we return here. So here in store refresh token, we can then say we have the hashed version of the raw token, which is equal to hash token, raw refresh token. We need the expiry milliseconds because we saved that in our database as well. So expiry milliseconds is information we've already saved in our JWT service. So we can simply retrieve this property here. And with that, we can then say the token expires at a specific instant. So expires at instant.now. And we simply add these expiration milliseconds to get the final instant. We can then save in our DB. Then we can say token refresh repository. I'm gonna save a new refresh token. The user ID is simply the one we've passed here. It expires at our expires at instant, and the hashed token variant is hashed, and credit at is automatically created. Cool. So now we have a utility function in order to store a refresh token, which we now obviously want to do after generating this token pair here when the user wants to log in. So we can say store refresh token. The user ID is simply the user object that we found in our db.id. And the raw refresh token is the new refresh token that we've generated here via our JWT service. All right, great. So now we have a function to log a user in. We have a function to register a user. The last function that we need in this auth service is a function to refresh a token, specifically an access token. So let's do that. And that's the last one for this class. We say, we have a refresh function, which gets a refresh token the user has attached. And the user now wants to use this refresh token as a kind of authorization in order to refresh their short-lived access token. And this should obviously also, again, retrieve a token pair. Because after refreshing, what we want to do is we want to swap out the old token, the old refresh token, when a user refreshes it. So when a user refreshes their access token. This process is called rotating the token. So we delete the old one, we insert the new one, so we generate a new one, insert that, and then respawn this token pair here again in this refresh end. What's the advantage of that? On the one hand, security, because after using a refresh token, we consider that as invalid. So it can stay around somewhere where an attacker might get access to that. And on the other hand, what this will achieve is that a user who frequently uses the app, so in our case, the note-taking app, for example, or website, a user who frequently uses that does not need to relog in, because our refresh token in our JWT service has a certain validity for 30 days in this case. And if the user frequently uses the app, that means that they also frequently need to refresh their access tokens. And every single time they refresh their access token, they also get a new refresh token, which again has this initial validity of 30 days. And the only scenario where a user would then need to relog in is when the refresh token expires, which automatically then implies that they did not use that to refresh the access token for at least 30 days. So if they don't use the app for 30 days, then the refresh token will be invalid for refreshing the access token when they then want to use the app again. So in that case, we would need to sign them out, and they would need to relog in order to get a new refresh token. That is how this whole process works. So here in our refresh function, we first of all want to validate whether that is actually a valid refresh token. So JWT service.validate refresh token, we pass that in here. If that's not valid for some reason, we simply throw, what do we throw here? Illegal argument exception, invalid refresh token, something like that. Then, if we reach this point, we know that this is a valid refresh token. That does not yet mean that this is a refresh token that belongs to the user who's making the request though. So that's what we need to check next. Val user ID is equal to user repository. No, actually not. We use the JWT service, we get the user ID from the token, and then we want to retrieve the user account from our database for that given user ID. So we say val user is equal to user repository, find by ID. This is already pre-generated for an object ID, which we can create here with the user ID. These nullable pre-generated functions here from MongoDB return this optional. So since Java doesn't support nullability, at least in its type system, which we have with Kotlin, where we can have this user question mark type, MongoDB works with these optionals here, which could be user, but it could also be non-existent. So what we can do is, in order to get a real value, is we can say or else throw, and we say we would throw an illegal argument exception where we say invalid refresh token as well. And then this user here is a non-null user, because if it would be null, you wouldn't find anything here for this given user ID. We would throw this exception and exit this code. What we can then do is we can say val hashed is equal to hash token, where we pass in the refresh token the user has attached from their client device. Then we can say we use our refresh token repository, and we want to find the token by user ID and the hash token. So we pass in the user ID, the hashed token, and let's actually pass in the user.id, so we have the real object ID. And if that is null, so we can again use the else operator, we again want to throw. So illegal argument exception, where we say refresh token not recognized. And we can say maybe used or expired. If that did not throw, that means we have a valid refresh token, and the token also belongs to the user who claims to own this refresh token. So next up, what we want to do is we want to delete the old token in our database, refresh token repository, delete by user ID and hash token, user ID and hash token. And then we want to generate a new token pair that we again save in our database. So new access token, first of all, the access token is not saved in the DB, but responded to the client. So JWT service, generate refresh token, generate access token. This one here, we say user ID, our string variant, and we do the same for the new refresh token. Here the suggestion is fine, just that we want to swap this out with the user ID. So again, generate a new token pair. We need to make sure that we now take this new refresh token and of course insert it in our DB. So we can recognize that the next time we call the refresh endpoint. So we say store refresh token, we say user.id and new refresh token, user.id. And then lastly, we return the token pair again, where the access token is our new access token, new refresh token must be refresh token, and we set this to new refresh token. Cool. That was our refresh function. However, there is one more edge case we need to consider in this function. And that is, if we take a look at this, we do write multiple different things here to our database. So on the one hand, we delete the old token and we then store the new token. What actually happens if this database call succeeds, but this one then for some reason fails? What we will then result in is some kind of trouble, because the previous refresh token is not in our DB anymore, but there's also no new token that the user could use in order to refresh their access token. To be fair, it's a quite rare scenario, but it's one that can happen, especially in applications where lots of requests are coming in parallel. And the typical way to deal with that is a so-called database transaction. So a transaction is in the end just do it all or nothing. And we can easily do this here with MongoDB and Spring Boot by just annotating this function with transactional. So what this will do is it will actually only apply all write operations, so that really change something about our DB, that not simply query something. It will only apply those if they all succeed, but if one of them fails, none will be applied. So then the token would also not be deleted if the second call would fail. And simply by adding this annotation, we make sure that this edge case can't happen anymore. All right, that was really most of the work for all these endpoints. What we of course need to do, if you watched carefully, we of course also need a controller for authentication. But since the main functionality behind authentication is now already put in this auth service, the controller's responsibility is really just to retrieve the request, the incoming ones for registration, login, and refreshing the tokens. So we just need to delegate the calls to the auth service. Here in our controllers, we want to say auth controller, make that a class. We annotate this with REST controller, just like the previous node controller, and we give this a request mapping of auth. So that is completely correct here. Then in the constructor, we do need to pass the auth service, which now contains all the auth related functionality for us. And then we can again define request and response type here. So data class, on the one hand, I want to define an auth request, which is a request that consists of an email and a password combination that the client makes in a JSON format again, email, password. And we want to define a refresh request. So just a request where the client attaches their refresh token as a string in order to refresh their access token. And then just like we did for the node controller, we can really just have our functions here. On the one hand, to register, which takes in a request body. This time I don't forget this annotation. Request body, we call this body, and this is now of type auth request because registration as well as login both just need to include the email and password combination here. We can give this a post mapping, since this would create a user here. In general, registration and login are typically implemented as post requests. And here we can then say the actual URL is /register. So it means the request would need to go to localhost port /auth/register. I think that's something we actually didn't do in the nodes controller yet. Take a look here. No, all these annotations, we did not provide any parameters except for the delete mapping with a path. But what we did here is really just to specify an even more relative path kind of just for the register endpoint. So we make the request to auth/register. Then for the function implementation, we would return an auth service.token pair here. That is the type of data we now want to respond with. And that's simply auth service.register with our body.email and body.password. And no, actually not. Registration does not return tokens, since here we just insert a new user in our DB. So here we don't want to respond with anybody, but just leave it like that. But then we can take this code, duplicate it. This time it's for login. We also want to attach an auth request, so that stays the same since we also need the email and password combination. Just that this time we do want to return this token pair, and we say we return auth service.login. And that also responds with some kind of error conflicting, because I still call this register. We call this login, and then we have those two functions. Now the last one is for refreshing. So there will also be a post mapping. Put this in here, post mapping. This will be going to the refresh endpoint. We call this refresh. The body will this time be a refresh request. It will also respond with a token pair. And here we can then say we want to refresh a specific token that comes from the body.refresh token. So now that we have our auth related endpoints, there are a few little things left. On the one hand, an important thing, but little thing, and that is in our node controller, we now don't want to attach the owner ID anymore in the client, but rather retrieve that from the actual token that was attached. And there are multiple ways to actually do that, but we definitely don't want to provide this as a request parameter, but rather retrieve this owner ID, for example, from the global authentication object, so the global security context that we've previously mutated in our JWT auth filter. So here in this filter that gets executed for every single request the client makes, and it will retrieve the user ID from the token, assign this to this token object here, and set this to the global security context.authentication object, which we could retrieve anywhere in the code base, as I said. So what we could do is we could go ahead here and say we set this equal to security context holder.get context.authentication.principal, that is the token information, and we convert that to a string, and then we again have a string. So this owner ID will now be the actual user ID of the attached token. And since for all these node controller routes, there must be a valid token attached anyways, this is a really, really nice way to retrieve the user information, who we want to respond, who we want to retrieve these nodes for. That's, by the way, also something we should consider here when deleting a node by its ID. Right now, we don't really check if the person who tries to delete this node is also the owner. So right now, there would probably not be a way for someone to know the node IDs of someone else, unless something gets leaked or so. But imagine at some point you maybe add a feature where one specific node can be shared and multiple people can work on that, can add content, but one of them is actually the owner, only the owner can delete those nodes. Well then, the other person might also have that node ID and could right now delete the node as well. So what we would need to do is we would need to check if that node is really the node from that owner who owns the token the request was made with. So well, node is node repository dot find by ID. So we find a node by its node ID. The ID that we want to find is an object ID with a path variable. And this is again an optional, so we can say or else throw. And for now, I will also say illegal argument exception. We will, by the way, change this slightly later on because we can do some optimizations with these exceptions. I will share more about that later. Here we could just say node not something like that. And then we can say if node dot owner ID is actually the same as the owner ID we can retrieve like this. So we can copy paste this. If the owner ID is really the owner ID of the person who owns this token and has attached it, owner ID dot, oh no, the owner ID here needs to be converted to a hex string since that's a MongoDB ID, then we want to delete this. And otherwise we simply don't do anything. And lastly, we also want to take this and paste it where we want to save a new node to retrieve the owner ID and then take this and actually attach it here in the owner ID object ID we're currently generating for every single new node. So this way we've successfully secured our node-related endpoints to really make use of this authentication mechanism we've now implemented. So I would say we try this out. As I said, there are still a few little issues in this code base that I will fix, of course, but we should be at a point where we can really try this out, where we can check if we can register new users, if they really end up in our DB. So let's run this code. I need to look at the port again, but I think I still have it in Postman. Yes, there we go. So we still have the endpoint here, just making sure that our backend is really running and that nothing crashes like here. Illegal base 64 character. Okay, what is that? Okay, for some reason it does not recognize my JWT secret. Let's quickly go to configurations. And I don't know why that is not a correct character. It says illegal base 64 character 5F. And we are retrieving that here. We are decoding it. And we are also reading this in here, right? And it still complains here that cannot resolve configuration property JWT secret. I feel like something is off with this one because we get a warning here. This shouldn't be there. And I'm actually a little bit dumped because this value, this string we've passed here, should not be the name of the environment variable, but the name or the reference of our application properties here. So this JWT secret, which is also why it's currently unused because we don't reference this anywhere in our code. Let's copy this. Let's go to JWT service. And specifically, we need to reference the value behind that property and not just that property name itself. And that works via a $$ and then our JWT secret here in curly braces. This is how we retrieve the underlying value behind this JWT secret application property and put it here in this variable. If we relaunch this, let's hopefully not get the same issue again. Yes, that is looking much better. Our backend keeps running. So we're now ready to test this thing. So here I am in Postman again, and I will simply create a new tab here to first of all try to fetch some nodes. So if we say HTTP localhost and we use our port 8085 and we try to fetch certain nodes, then if we just make that GET request to that endpoint, we will get internal server error. So that definitely does not work anymore to just retrieve a token. If we take a look on the server side, then the exception, we can see this here. It says something like state should be hex string has 24 characters in our node controller. So this specifically failed here because Mongo object DBs have a specific format, specifically 24 characters. And right now, the principle here apparently was just an empty or a nullable string, probably an empty one. So it complains here. Well, let's actually try to register. So we have a register endpoint. We select post. We give it a body. Click on raw to attach a JSON request. And we now want to register with an email, which may be test@test.com, and a password, which we can set to something like this, test12345. If we now send this to the actually auth register endpoint, that is the one we've specified, click send, that was okay. So we got a valid response. That means, okay, the registration was successful. We can also check this here if we go to our Mongo Atlas, actually refresh the database. And we do have this users collection with our test@test user and the hashed password. So you can see that's definitely not the test12345 password that we've chosen, but a different one. Awesome. Next thing we can test is logging in with this user with the password we've chosen. So if we now take the login endpoint and we take the email, same password, now let's actually first choose a different password to see that this actually fails. Click send. This gives us forbidden, which is, by the way, not the correct status code that we should respond for this, but it definitely does not let us log in. 403 forbidden means that we attached valid authentication information, so we attached a valid token. But with that token, we still don't have the privileges to access a certain resource, like a certain URL or so. Very typical use case would be you are a normal user and you try to call a route that is only for admins. This information about the role of you could of course also store in such a JWT token to only allow users to call specific user routes and only allow admins access to all routes. But if a user makes a request with a valid token to an admin route, this can still be denied, and in that case we would say, hey, you have a valid token, but that token is not for this route. This is not what we should return here, and that is one of the issues that I will get to in a moment. We should instead respond with 401. That would be typical to say, hey, you lack authentication details, or your authentication details are just incorrect. But hey, that's still a first success, since we do get an error for an invalid login. If you provide correct login details, click send, we do get okay. And here we get our token pair, our access token, and our refresh token. And ideally, this should now also be saved in our DB. So if we refresh this whole thing again, then we do have a refresh tokens table, or actually collection. Here we have our refresh token, the hashed version of that. We have the expiration, we have the created at timestamp, and the user ID who this token belongs to. And this access token that was responded with here is now valid for 15 minutes. And with that, we can authenticate requests, for example, to the nodes endpoint. So we can say we try to create a node, HTTP localhost 8085, let's say /nodes. And here we now need to attach this authentication information, this token that we've previously retrieved. So here under headers, we want to specify this authorization header. And then we specify it in the same format that I shared with you before. So bearer, and then we simply paste the access token. And under body, we then declare the actual node we want to save in our DB. So on the one hand, we do need the owner ID we don't need anymore. We do need the test title, content, test content, and we need to choose a color, which is actually not a string, but just some kind of long value. The owner ID we don't need to pass anymore because this is contained here in our token that we attach to the header. And without this token, we can't make a request to this endpoint anyway, since it's an authenticated one. So if we now send this to our server, we do get an OK response with our node that was created. And if we now go to Google Chrome again, and we refresh this once more, and we do take a look in our nodes, then we do see this test node that we've inserted here. And here you can see the owner ID was still somehow passed thanks to our token. And we can now verify this, that we take a look at this owner ID, it ends with an A8. And we take a look in our users collection and make sure that the ID of the user, yes, that also ends with an A8. So that a user ID was properly retrieved from the token. Let's also test this refresh token mechanism. So we do have our auth refresh endpoint, which is now used to refresh this access token, which expires after 15 minutes, via this refresh token, which expires after 30 days. So we take this refresh token, which again, we would have saved somewhere locally in preferences, in persistent storage, in browser cache, also, actually not browser cache, but in your browser, in order to use that to refresh the access token. So we copy this, we go to here the JSON body, since that is where we attach the refresh token that we now want to use to get a new token pair. And if we now send this, We do also get an OK response with a new token pair. And with this access token, we should now again get access to this endpoint. So we could just post the same node again. If we now send this again with the old token, this should now be invalid. So we can also test this. We click send. It gives us OK, because this access token is technically still valid. As I said, 15 minutes in total, but after that expires, it would give us invalid. So in a real use case, that would not work unless you do all this in a 15-minute window. But what we want to test is that the new access token can actually also be used in order to make a valid request. Yes, it can. And in our DB, we should only have a single refresh token document here in our collection. And yes, there it is. So the previous one was deleted and the new one was inserted. Very good. We already have a somewhat working backend, but as I said, there are still a few issues. Let's go through them step by step. On the one hand, when we register a new user, so if we have our register endpoint, we've previously used the email something test@test.com, test@test.com, and we have the password test12345. Once we did that, we actually don't have any form of server-side validation for the data that the client here passes to the server. So the client could technically just create an account with a completely invalid email that isn't even a valid email format, and they could also technically submit a blank password. So something like this, or just having a 1 as a password or so, that would still be okay, and that would still insert something in our DB. In a real-world environment, you would want to validate these emails to say, hey user, you entered an invalid email, please correct that. Hey user, you entered a way too insecure password, please use one that has, I don't know, at least an uppercase character, a lowercase character, a digit. You all know that, but currently we don't enforce that at all server-side. That's one issue. Another issue is that our response codes, our HTTP status codes, are not fully reflecting what really happened server-side. You've seen this before when we got this internal server error for when we tried to actually retrieve nodes from the nodes endpoint without attaching a token. The valid or the correct response code would have been 401, that we say, hey user, you don't have authentication information attached, but it actually responded with internal server error. So for certain scenarios, we want to just be a bit more specific with the response codes to better tell the clients what went wrong. And one last thing we should do is we should configure our security filter that we've created very, very early in this course with the CSRF protection. But we can extend that to actually say that we have a set of routes, URL endpoints that are authenticated, like our nodes endpoints in this case. And we have a few that don't require active authentication, like login, registration, and the refresh token endpoint. All these don't require an auth header to be attached. So let's do this step by step. Let's just start with the last one, since this is probably the most important one. To go to our backend, we go to our security config. And here, after session management, we also want to say authorize HTTP requests that has this lambda function. Here we do get the auth object. And with this auth object, we can now kind of set rules based on which routes should be protected, authenticated, and which don't need to be. So specifically, we can say auth.request matches. And here we can define some kind of a URL pattern for routes that we want to apply certain rules for. So for example, auth/**, and we say that permit all. So what that means is we match all requests to the auth endpoints. So whatever kind of auth endpoint, whether that's login, registration, or refreshing, all of these we always want to permit without authentication, without the user having to attach a token. Because at this point for these endpoints, there is no token yet they could attach. Also something we want to do is, we want to say dispatcher type matchers, and we set this to dispatcher type error and dispatcher type dot forward, also called permit all here. What this will do is, if a request actually results in an error, for example, then Spring Security, which applies this security config, won't intercept that request. Because what typically happens is that if you don't do this and a request fails, for example, because of a bad request, so the client attached some data that's simply invalid, that we can't parse into our data classes from JSON because its field is maybe spelled incorrectly or so, then this would technically be a bad request error that Spring Boot would correctly map to or correctly respond with But if we use Spring Security, the default behavior is that it will just see, okay, something went wrong, respond with 403. That is what Spring Security always does. So just a 403 forbidden error will be immediately returned before this other more specific error can even reach the, can even be thrown, can even be responded with. And by doing this, we say, okay, for all kinds of errors, we really want to have this more fine-grained error handling, and same for forwarding, so that Spring Boot will really just enforce the security rules for, let's say, normal requests. So last thing we want to do here is we want to say any request dot authenticated. So this will really just say, after applying those specific rules, any other request requires authentication, requires an auth header to be specified. And these are the rules that Spring Security will use and work with in order to then, for example, respond with 403, 401 if there is no valid authentication attached. We can then also say exception handling, and we want to say it, so the exception handling configurer, we can also give it a name, figurer. We use that one, and we set the authentication entry point to an HTTP status entry point, and we say HTTP status unauthorized. So what this will do is if authentication fails, then we by default want to respond with 401 instead of 403, which would be the correct status code, for example, for invalid credentials. Since, as I said, 403 is just meant for valid credentials that still don't, that still shouldn't access a specific route. And then we can pass in our JWT auth filter, since we want to make sure that we apply this logic before this one. So both these would be valid filters that somehow change something about the request. So this one would validate the security side, and the JW auth filter would update our auth object here. So we can then say, we want to take this current filter and add this filter before the JWT auth filter. And that is actually a username password authentication filter, ;class at Java. So this is one thing about our security config that we needed to change. Another thing is that we want to be a bit more fine-grained in our response code handling, as I mentioned. So right now, if we go to, what was that, auth service, I think. Here there's a bad credentials exception that already comes from Spring Boot and kind of includes the information that the credentials were incorrect. But right now, we don't do this for every single exception. So for example, here, if the refresh token can't be validated, we throw an illegal argument exception, which would really jump out of this function. But what this would also do is it would automatically tell our server, which is currently processing the request here in this piece of code, it will also tell it, hey, something went wrong. You have to respond with a server-side error, because illegal argument exceptions don't themselves have anything to do with the request itself. So the moment we throw this in our server's code, our server itself would not completely crash. It would just print the stack trace. But this would result in the server responding with a 500 error, so a server-side error. Even though in this case, it's actually a client-side error, because the token that the client attached was simply incorrect. So the client could alone fix that by attaching a valid token. And the way we can work with these more fine-grained errors to say, hey, at this point, make Spring Boot actually respond with a specific status code if this check fails. In that case, we can simply throw in a response status exception. We can give it a specific method, but most importantly, we do need to pass a specific status code that describes what went wrong. So we can say HTTP status code value of 401, and this would now respond with a 401 error that the user has simply bad credentials. And the same thing we can actually do here. So if there is no user, we don't want to keep this throw here, but rather just wrap this in here. But I guess we could also say throw. I think that wouldn't change anything here. But since this function already takes a look at the value, if it's null, it would simply throw this. Here we could argue what we actually want to respond with. So 401 would indicate, hey, there are invalid credentials. In this case, what this would actually mean is the user ID that this token belongs to is actually not in our database. So another appropriate status code, I would say, is 404. So probably the most popular status code that simply means not found. So you wanted to find a certain resource, but you didn't find it. Since we still say invalid refresh token, I would say we leave this at 401. But if this would be a status code the client would need to care about and would need to understand that it's this specific part of the code that through an error, then I would say 404 is also very appropriate. And here, for this one, we can also throw this exception. Let's actually copy this part of it, paste it here. In this case, we would also want to throw 401, I guess. So if we don't find a user who belongs to this hash token, so this could still be that the token is valid but doesn't belong to the user, yes, in that case, I would say we also respond with 401. Is there anything else where we throw exceptions? Not in this file. Here we do, but that's already fine. I think there is still another class, another file where we might do that in the JWT service maybe. Remember, yeah, here's also an illegal argument exception. If we fail to parse the ID from the token, so the user did not attach an auth header, for example, then we also want to say we throw this response status exception like this, and we say invalid token. All right, that should be everything regarding this more fine-grained exception handling. Next thing, as I mentioned, is we need to validate the fields for registration. And the cool thing here is we don't even need to do this now around, because I already included a package from Spring Boot itself, which is this one here, Spring Boot Starter Validation. That is a package that makes it super easy to validate incoming data from clients. In our Auth controller, the way we can apply this is, we first of all, of course, need to know which specific data we want to validate in which way. But for the auth request, we want to definitely validate the email and the password. So for the email, we want to make sure that this is actually an email. So we can say we annotate this with email, but actually not just with email, but we need to make sure that we annotate the field value of that. And we could also then give this a message if this validation fails. So this email annotation just tells our Spring Boot validation framework, hey, we want to use a normal email format here. And if this fails, we give it a specific message like invalid email format. For the password, well, things are a little bit more complex. So we could still say field, and then there are lots of different types of validations. We could also say not blank, for example, if it shouldn't be empty. But what we can do is we can apply a pattern, so regular expressions. Make sure to import the Jakarta validation constraints here. And then we can provide a regular expression that I will simply paste here. So I don't need to type this off. Feel free to copy paste this from GitHub or just type it off very quickly. This regular expression simply matches all passwords that have at least an uppercase, a lowercase character, a digit, and are at least 9 characters long. And if this validation fails, we can also give it a message by saying password must be at least 9 characters long and contain at least 1 digit, uppercase and lowercase character, something like this. For our nodes, so in the node controller, the node request, here we could just say, for example, that the node title should not be blank. So there must be a title. Because in general, it's always the best idea to apply data validation on both client and server side. On client side, we do this for usability so that we tell the user if a node has maybe an empty title and they need to enter that. On the server side, we validate for security reasons. So some people couldn't just fake requests via Postman, for example, to insert data into our database with empty titles, with invalid emails, something like that. You get the idea. These messages that we can create here, so here as well, title for the node is required, something like that, or title can't be empty, title can't be blank. These messages that we create here are for now just visible here in our code, so they won't by default be attached to the error response that our server will automatically respond with. So the moment such a validation, by the way, fails now, Spring Validation will respond with a bad request. So this can also be a valid use case for responding with a 400 bad request error that the data and the JSON structure itself matched, but you say, hey, that was not a valid email. If we still want this and want to attach this to the final response, what we can make use of is a so-called global exception handler. That's a pretty cool thing of Spring Boot, that we can do something like this. So in our root package, we create something like a global, let's call it global validation handler. So just for validation related errors. Annotate this with REST controller advice. And you will see in a moment what this will result in. We then have a function handle validation error. This will take a method argument, not a valid exception. And we annotate this with exception handler for method argument not valid exception. So what this does is, we have this global validation handler. Specifically, this function will now be called for every single method argument not valid exception that is thrown in some kind of endpoint, in some kind of code where your client makes a request. This is just the type of exception that the Spring validation framework throws. And with such a global validation handler, we can intercept that now. And we can say, this is now the way how we want to handle these kinds of exceptions across our code base, across our backend. So here what we can return is a response entity, which just includes information about the response we now want to send back to the client. A response entity of map string to any. So this could be just anything, just a typical JSON structure. We have keys in any type of values. But what I want to do is I want to have a list of all errors that actually happened here by saying or exception, binding result, that all errors, and we map these to their default messages, or we say invalid value. And if we then say return response entity, it will all make sense in a moment. Response entity, that status 400, that body, and we attach our errors, or actually a map of errors to errors. What pretty much just happens here is, for every single type of method argument not valid exception, when validation for any field in our code base fails, this code will be called. We retrieve the errors which are attached to the exception in this all errors list. We map these errors to their corresponding messages we've set. So here, these strings that are just a bit more descriptive about what went wrong. If we did not provide such a default message, we will just say, okay, that's an invalid value. And then if such an exception is thrown in our code, we simply respond with HTTP 400, so bad request, and we attach this body instead of what Spring Boot would have done by default. And I think that, and one last tiny thing we need to do is, in our application properties, we do need to explicitly opt into MongoDB auto-creating these indexes. I don't know what the plural is, but this thing that we have in our refresh token, here this index, this only works if we actually created this index before, and by default this annotation won't create this automatically. We can, however, opt into that and say, hey MongoDB, please do that. So we can say spring data.mongodb, and then something here, auto index creation, setting that to true, because that way this index will be automatically created and these refresh tokens will be automatically deleted once they expire. That's something we don't need to manage anymore. But I think that's pretty much the backend. So I would be super happy to try this out and hopefully everything works. There we go, it doesn't crash. So we can now go back to Postman, try to register with this invalid request body. And by the way, another edge case that we need to think about is if a user tries to register with an email that already exists. So we will implement that in a moment. But let's just have some kind of invalid email, definitely invalid password. If we now fire this off to our server, this goes through. It shouldn't. Why is that? Let's take a look in Spring Boot. Is this actually arriving here? No, we did not even get a request. What is going on here? So we do have our write port register. Did this end up in our DB? Let's quickly refresh this here. So we have our user, and yes, our email is ending up in here. So something must be called here. All right, sorry, forgot something again. It's already a bit late here. But what I forgot is another annotation. You can see Spring Boot heavily makes use of all these annotations. It's very easy to forget that. But if we make use of these field annotations for validating a specific field, we also need to explicitly tell a request body that we want to apply that. So here for registration, we also need this valid annotation in order to say, please validate this particular request body. Same thing for login. For login, we don't need that, because if the email is invalid, then it doesn't match for sure. For the node controller here, we also, by the way, need this field annotation, which I also forgot. Field annotation for not blank. And then when we save a node, we also, first of all, want to validate that. And something we nowadays also don't need anymore is this Spring Security User Password Test, since we now have a proper security setup here with our security config that will work for both production and test. Let's relaunch this again. I'll try this once more. There we go, server launches. Here we again have our invalid request body now. Let's change this to something else. This should now really respond with a bad request, since what we have here right now is definitely not correct data. If we send this, we do get bad request, finally. And here our request error handler also works. So we get the list of all errors just as a list responded to the client. We see, okay, the email is invalid and the password is actually also invalid. So if we fix the password thing, test 1, 2, 3, 4, 5, so we have an uppercase, a lowercase, and at least a digit and 9 characters, and we send this again, we get bad request, but this time just with the invalid email format. If we attach a correct email format that is still currently existing in our DB, let's say test2.com, this now works. Perfect. You will notice that the Spring Boot validation framework is not exactly the most correct validation for email addresses. So specifically, if we remove this dot here, this is definitely not a valid email, but this will succeed. This is not an issue of our code. This is just that Spring Boot validation will not apply the super strict email validation, since validating emails is incredibly complex. But in a normal environment, you would probably want real validation. So in that case, I would look up a more fine-grained regular expression that also validates email addresses. But for getting started for a course like this, where you just familiarize with everything, this is perfectly fine as we have it. If we now want to use this for logging in, then another thing we actually did is, if this is not valid, so there is no active user account under that, under those credentials, we send this, then we do now get unauthorized. So that's a correct error code that tells us, hey, you provided invalid credentials. If we do log in with a valid account, then we get the access token. We can make our request to the node endpoint, so localhost 8085/nodes. If we want to retrieve that and we pass our authorization header here, authorization, bearer, paste that in here, and we just want to retrieve our own nodes, click send. Then we do get forbidden, interesting. Authorization, no, that is actually is that the right token that I copied over? Yes, it is. So we do attach this token to the nodes endpoint right here, but it does say forbidden. Let's take a look server side if the logs say something. Let's take a look in our node controller, which is the one that's called here. Specifically this find by owner ID. Okay, that issue is a quite weird one, to be fair. I looked into it and I also needed a little moment. Why does this happen? If we go to IntelliJ, this username password authentication token actually expects us to pass in this third parameter, the authorities, and it expects us to pass an empty list. That was also new to me. I have no idea why we need to pass an empty list. I thought that was the default value, so we could leave it out. If we pass this empty list, it works. If we don't pass it, it doesn't work. I have no idea, honestly. So let's change that. It'll run this. Take a look in Postman after it actually started. Yes. If we now click send, then we do get unauthorized. This could be because the token just expired, but in that case, this would be correct. So we can try refreshing this token. Here we take no, actually that's the access token. If we go to our login, we have this refresh token. We can call the refresh endpoint with that. So HTTP localhost 8085 auth refresh. Here in the headers, actually not the headers, but the body, we do attach our JSON. We say refresh token is equal to what we copied before. Make this a post request, click send. We could refresh that, perfect. We copy over the access token to the get nodes endpoint. Make sure to swap this out, and now it should not give us unauthorized again. Yes, it retrieves our nodes. We are successfully authenticated. Very nice. That was quite a lot. Let's also try to delete one of these nodes, by the way. So we take the test title node, for example, and we call the delete endpoint. So delete. This takes in the node ID as a parameter. We do need to be authenticated. Since we own this node, this should also give us, okay, yes, if we retrieve the nodes again or take a look in our DB, this should also now show that we only have 2 remaining nodes in our collection. Here, nodes. And that is the case, so the node was properly deleted. Perfect, perfect, very cool. I think that's a working backend. As I mentioned, the last little edge case is that a user tries to register with an email that already exists. That's something we could easily check for in our Auth service. That would be when we try to register. So we don't just want to blindly save all kinds of users, but rather want to check, okay, user is equal to user repository, find by email, pass in that email the user has provided, and probably also trim it. So we remove the leading and trailing spaces from this. And if this user is not null, so if it exists, there is a user we found with this email, then we can say throw response status exception. In this case, an appropriate status would be a conflict. So there was some kind of server-side conflict that still originated from the client's inputs. So we could say status code conflict. And we say a user with that email already exists, something like that. And otherwise, we save this user in the DB and return it. Relaunching this, taking a look in Postman, taking a look in the, let's say, the register endpoint here, we call register. We do want to register with the user that exists already. Let's use that. We hit send, and there is our conflict. Yes. So that is now also working. I really hope you learned some Spring Boot with this. Of course, this is really just the tip of the iceberg when it comes to backend development. But I really try to put everything that kind of belongs to the base knowledge of building backends here into this course. Authentication is typically something you need in any backend. Storing something in a remote database is something you need in any backend. Being able to understand all this Spring Boot component functionality, how to pass around classes, what a component is, a service, a REST controller, request mappings, validations, all that typical stuff you just need all the time in backend development. I hope that is now clear. Of course, it will be completely normal that there will be aspects of this course that are not that don't fully stick yet. That's normal. I recommend just build your own backends, build certain clients, maybe get into web development or get into app development. So if you want to get into app development, then my channel is full of that. So please leave a subscribe. You will find lots of content about native Android, but also Kotlin multi-platform. So if you like Kotlin as a language, you can also build iOS apps with that, Android apps with that, desktop apps with that, and even websites nowadays. So Kotlin is really a really cool language to build software for the entire software stack. If you enjoyed this, leave a subscribe. Click down below, do that now, and you won't miss any future backend related videos anymore, and also mobile related ones. Thanks so much for watching this far. I really hope you enjoyed it. Let me know in the comments how you liked it, if there's anything I could have done better. I know some parts were a little bit of a mess, but I know that people like it when I also leave in these errors. That my coding style is also not perfect. I know YouTube is often sunshine and rainbows, but the real world is that also YouTubers who make programming tutorials run into errors and also don't immediately know why they are actually caused. All right, thanks so much. I will see you back in the next video. Have an amazing rest of your week. Bye bye.